Priya added a hotel to her flight just because it had a floating breakfast. Expedia, made to travel.
मॉर्निंग में 11 बजे मैंने अपना इंस्पेक्शन बुक किया था। जो स्पिनी से इंस्पेक्टर आए थे वो काफी ऑन टाइम आए थे। मेरी जितनी भी क्वेरीज थी उन्होंने अच्छे से आंसर करी। सो बेसिकली जो प्राइस में जो कोट हुआ था ऑनलाइन और जो लाइक फाइनल प्राइस मेरे को रिसीव हुआ है वो काफी अच्छा था एंड मैंने एक्सेप्ट किया। बाय 4 लाइक आई वाज एबल टू सेल माय कार। डॉक्यूमेंटेशन भी पूरा वही देख रहे हैं और बेस्ट पार्ट है द बेस्ट प्राइस।
National Board of Accreditation and served as the chairman of GATE AIC Zone during 2010. He is also an active volunteer of Earlier, he held the position of the chair for the IEEE Photonics Society and IEEE Communication Society Bangalore chapter. Let's give a big round of applause to Sir. We are truly honored to have you with us, sir. At this juncture, I would like to request Dr. Tabassum Aura, the convener of this FDP, to kindly present a token of appreciation to Dr. Srinivas. Thank you all. I once again extend a warm welcome to our resource person and all the participants. Over to you, sir.
Yeah, there's something right now. So probably
आपको चार्ज एक बन के
Okay, let me do the PowerPoint itself. Yeah. Hello. Oh, is that so? Oh, I was. Yeah, let me just check up because I am already in the lecture. Okay. Okay. Maybe slightly less because I am in the lecture, so I'll have to manage both. Okay. Yeah. Okay. Okay. We'll try to multiplex. We'll continue, but I'll do simultaneously. I'll listen that and speak here. First, let us start with a brief intro, then we'll get going. I think let's get started. I know you already had a lot of information on quantum and a lot of things. I was told that you had. Is it too far or? See, we would like to have a lot of. This is a physical way that we are meeting. So it's very good that we interact more. Okay. I was thinking if I can sit there, this cable will not come up to that point, I think, is it not? If I sit there, because I can interact more, most of them are that side. No, just a minute. We don't want to disturb them, but. Hmm? Oh, that is also a good idea. Hmm? We can walk or sit there or. Because there will be a lot of extra information, so we don't need all those things. Oh, do you have a slide changer? Yeah, do. We'll do that. So, please connect a slide changer. Because you see, of course, there is another. Oh, this side also you have. Okay. All these extra things we'll keep aside for some time. See, we have a lot of time is given to us, and also enough material is also there, depending on your interest. Okay. Just let me first check up. So this is to the laptop only. The receiver is. It's okay. We'll manage. Hello. Yeah, it's good to have good interaction. I have to multiplex with another. Asking them to prepone, but. Yeah, okay. Yeah, we'll manage. Don't worry. You have a Wi-Fi setting? Hello. HKBK Wi-Fi. So we can go to
AICTE-FDP. AICTE.
Actually, Vijay Kumar sir is not responding. You tried Vinu madam? But Vijay Kumar sir.
This is connected. Hello. Hello. See, if you have a difficulty, we can wait. There's no problem. Okay? Dr. Prita Sharan.
Yeah.
If you have difficulty, I can wait. There's no problem. I am parallelly doing another talk. So I'll break whenever you want.
You'll be here on the morning.
Okay. You please let me know. If you want me to break at some point, I'll break it and then we'll listen to this for some time. Okay? Okay. Going. See, this topic is, of course, most of you are now into this quantum area. A lot of topics I know that he mentioned me that almost this is the last day. Yeah, that means most of the quantum you know. What you may not know is the other line, the photonics. So how it is connected with quantum is an important thing. So the main motivation for us is, see, we are talking about quantum and all these things in different technologies. Like you must have learned that the most common technology is called the superconducting qubits. The implementation, if you see the IBM's, this thing, and many other places, if you see, they try to implement using superconducting qubits. In some places, they will use atomic color centers. If you go to Raman Research Institute, Dr. Urvashi Sinha works on quantum information using color centers and these things. There are a lot of technologies like that. But we want to compare with the developments in electronics. See, we see all these devices that we see around are all electronic devices, like cell phones, laptops, TV. These are all electronic devices. Why this technology has become so important? Why we have so much of information technology? This is mainly because of the developments in VLSI. Everything has become small. So if you want to compare what happens in future about this quantum, we want a technology similar to that. We have to implement whatever you have tried, like logic gates or computer architectures. All these we want to observe or see in a small scale, like in VLSI circuits. So how does it come? What is the technology which will provide that? When you get a finally, after 10 years or so, if you have a quantum chip in your laptop, how does it look like? Is an important question. What we would like to see. Right now it is not there. But we want to foresee the scientists or engineers like you, we have to work towards that, to realize that. So what is the technology which will give that? That is that second line. Photonics. So photonics can be said to be science and technology of using light waves for various applications, starting from optical communications to fiber optic sensors to biomedical applications to quantum computing. So people foresee that optics is the real technology necessary for quantum. We may or may not have. We may not have the knowledge right now. Globally also, we are very primitive. If you look at the current literature, you will see more and more optics getting into the quantum. That is motivation for our. So all that you have learned until now, like the qubits or some logic gates, all these we should see how they can be implemented using light waves. And as you know, we should go to smaller and smaller dimensions, like atomic dimensions. All the quantum phenomena appear when you go, and on the earth at least. See, we are on the earth, all phenomena appear to be classical. Is it not? Like the movement of objects or the electrical circuits or dynamics and all the phenomena, they appear to be classical, large scale. We according to our perception, quantum is a large scale. I mean, the classical is a large scale, quantum is at atomic and smaller scales. That's what is a human perception. But there are very simple indicators that it is not only large scale. For example, the colors of these objects or the strengths of these materials. These are all, if you want to understand them, we have to go to atomic level. Then only we can say that this is this color, this is this color. The most prominent one, fundamental questions that we have is, what is light? Light is playing an important role in our daily life. We use geometrical optics, physical optics, etc. to understand these properties of light. But the light is the real quantum object in our planet, on this world. I mean, just I'm trying to see where all these things fall. I'm not simply taking it as an FDP to see, that will come in a minute. So our real world, we have to understand a lot of things. We have basic questions. As an engineer or as a common man also, we have questions. What is this light? In the college we have studied geometrical optics, Newton's optics, light propagates in straight lines and all those things. But at this moment, the subject of photonics has grown a bit. Not so much as electronics. The direct indication for this is fiber optic communications. We have fiber optic cables all over the globe. We have a national backbone network. All your high bandwidth applications, including your mobile communications, is only due to fiber optic communications. Otherwise, you cannot watch a movie on a cell phone. See, the fiber is coming up to your tower or to the home. Now you have fiber to the home. Is it not? 200 Mbps or 500 Mbps they give you at the home. What is the data rate going on in the globe or the national backbone network? 10 Gbps. We cannot imagine so much bandwidth if you are using copper cables or coaxial links or troposcatter links. Conventional communications could not cater to such a bandwidth. And many, many applications are not possible. For example, big data applications. So much of information we can never touch without large bandwidth. So there are so many such things motivating for us to go for fiber optics. So the similar thing you can think of sensors. Sensors can become, we don't want to go deeper into that. Sensors can become very, very sensitive. Compared to, see, in college also we know, if you want to measure the radius of curvature of a watch glass or lens, use optical technique. We cannot measure the screw gauge or these mechanical methods. Is it not? Mechanical methods of this order of a fractions of mm, that is the resolution that we talk about. Electronic techniques, you can go up to a few micrometers. We can measure using electron microscope and other devices up to micrometers or slightly less. Nano also we talk about, lithography, we talk about up to nano. But what are atomic dimensions? Still smaller. If you want to understand the properties of atomic systems, you should go to still smaller. You see, it is measured in terms of the wavelength that you are trying to use to probe this. So light wavelengths of the order of a micron. That is also electronic resolutions only. But what is more finer? The frequency. Frequency of light is of the order of 10 to the power 14 hertz. That is much larger than our electronic bandwidths. Microwaves you got 10 to the power 9. These are microwave gigahertz. Fiber optics or optical frequency is 10 to the power 14. So 10,000 times more. So much resolutions. You can do picometer or picosecond resolutions with optical techniques. So, a lot of activity. I think there is one slide I'll show you. Just a minute, let us reduce them.
This is that. This side of the book that has joined first.
See, all that she's talking, I know. So, this is the motivation to go for photonics. Okay? All your quantum whatever you've been studying or whatever is happening, they will assume some superconducting techniques. See, there is one company called QPI, is it not? Those people have come for your... Oh, see, it's very difficult nowadays because everywhere you are doing quantum. Of course, it's good that you, I'm very happy that you have shown interest in this, but it's very difficult to get...
And then we have seen regarding the Maxender's quantum split and all the tackling with the photons behaviors.
See, gradually people are coming to this, but technology is not ready. You see, what you may have seen, observe. See, for example, if you go to PRL Ahmedabad, they have optical techniques. They have a big optical table. On the optical table, they can show all these things. Interferometer, then splitting of photons, then qubit states, all those things they can demonstrate. That is next step I have to talk right now. In this discussion also, we'll focus on to what can be called as integrated photonics, not simply normal photonics. You have to get photonics onto the chip. That's the main emphasis that I'll go. And if you people are interested, I can show you a lot of photonics also. See, that is the area of interest in our lab. We work on integrated photonics for different applications. So let us get going. You please ask me a lot of questions. See, my take in what I would suggest is you pick up some topic of interest. I think some of you would like to do some PhD. You would like to take up some projects wherever that is possible from SERB or government. This is one of the motivations for attending these talks, I know. But that, of course, you have to put your regular effort. I'm not trying to disturb your regular flow of your patterns, whatever you are thinking. We want to add a little bit to that. By my presence or my involvement, what I would like to say is, at the end of this FDP, you go back, a lot of resources are given to you, papers, books, and so on. So you pick up what is that you are interested, really interested, and then start pursuing that. And then there are a lot of groups, including if you had made a WhatsApp group for this, you can exchange information, papers, and so on. I know that you may not have encountered much of photonics, so we'll give you information on photonics also. There are a lot of textbooks where they will use optics as an important implementation thing. Okay, anyone has I suppose anyone has talked about optical techniques for all these things, physical implementation. I know many of you are oriented towards the computer science. See, actually, that also I should make a comment. Many subjects, in particular this subject, you will need knowledge of your algorithms and so on. Of course, my interest is on the physical side, but it's a combination of many things. We cannot say that I'm a computer science person, I will not learn about hardware or something like that. So please make up your mind. You don't think of this. In fact, nowadays you have this department of AI, you have, is it not? Similarly, you think there is a department of quantum information or something like that. In future, it will happen. You will have to introduce a BTech course in quantum. Is it? You have MTech.
Well, in our college, they have not courses.
Yeah, specific courses, not full MTech, but specific courses are there in MTech, I think. Is it not? So this is a very challenge for us. Actually, this subject was not there some time ago, about 5-10 years ago. So we have to now take up, and we may have to teach some of these. So how do we do is an important question. That's why they are promoting these FDPs. It's not simply to see the one part I just now mentioned is someone wants to do research or take up projects. Other motivation is if your institution introduces this MTech or some elective course in quantum, etc. What do we teach is the question. So you have to learn a lot of things. Learning is one way, teaching is a different thing. I think most of your teachers, you know. So later, lot of information will pump, and you choose from that. Okay, and we'll have a lot of interaction. You ask us, and we will discuss. So let us get going. Then a lot of things we'll discuss. So my emphasis is on understanding and learning. One important thing that I noticed even now is, of course, for practical purposes, we are doing a lecture like this. But the best way to learn this is by yourself. At the first step itself, we are not convinced what is this qubit. Why it should be in two different states simultaneously. And many phenomena like entanglement. What is this? It's not common. These are all the things we should clearly understand for ourselves. Generally, if you are inquisitive, we will never get convinced. We have to accept. That's what most people are doing. You just accept that there is a qubit with two different states, superposition, giving the actual state. I'll do the same thing now, but when you go home, you please try to check up. You convince yourself. It has happened. In fact, even now, people are not convinced. I mean, of course, higher up people like Einstein or some bigger people, they would have already convinced. But for a common man, it is not at all convincing. Quantum phenomena or relativity, etc. But they are real. A lot of applications are there now. Science has progressed drastically. So the brief summary. Brief summary of what I have put. I have not. There is a more set of slides on photonics that I will take up later on. This just quickly. Most of it you would have already heard from other places. The extra thing that I will put is I will introduce how optics is coming into each. Suppose you say NAND gate. How do you implement that in optics is a question. Such things we'll discuss. So history you must have already heard. You must have learned about what is qubits. Then some simple systems like quantum gates you must have. For debate, I am ready. You must have already, even though you have studied, we can debate. So this. So that programs on photonics. And then in India also we have National Photonics Program. Then many academic institutions are starting these programs on, see, as I said earlier, it's not only for quantum, it has got fiber optics, sensors, and so on and so forth. So many institutions have started programs on photonics. For example, IIT Madras has got MTech in photonics. Most of the institutions have got R&D. Many faculty members are working on those subjects. Even in colleges like yours, some of them are interested in photonics. They are doing a little bit. Small scale is also okay at the college level, because we know your other commitments, load, and all those things. So if you're interested, it's very useful. Most of the people, I suppose, because I have come to you this FDP, I hope most of you will get interested in photonics and you will apply it to quantum. On the way, you can use it for fiber optic communications, all those things. Or I can highlight if you want. Just for discussion, because you have spent already 1 week. See, actually, I would say, even though I have said on the earth, on the planet, we have all this. If you take universe as a whole, almost fully 100% the phenomena are quantum, like gravity. For example, you have the sun is there here and some other galaxy is there. How are they interacting? How do you see? Or even simpler thing, Earth is there and Moon is there. You know that they are connected by gravity, m1 m2 by r square. So how quick, suppose there is a movement in the Moon, then the changes, force changes, is it not? How quickly does it is an important question. People say that signals cannot propagate more than speed of light. Is gravity following a different speed is the question. People say that all phenomena, the maximum limit is speed of light. Then gravity itself, suppose if some pulsar is oscillating, then what should happen? It should emit gravitational waves. Like moving charges, you emit electromagnetic radiation. Similarly, moving, pulsating objects should create gravitational waves. So at what speed they move? And then waves, we know now, you must have studied in this course, they are all quantized. Do you think gravitational waves are quantized? It's all real. There are a lot of physics, advanced physics going on, and quantum effects are there with gravity also, quantum gravity and all those things. Nothing deterministic. The whole world, only on planet we have accustomed, we have evolved to be deterministic. Everything is probabilistic. Particularly, our understanding, if you go to atomic level, the position of an electron, or the spin of the electron, or polarization of the photon, these are all probabilistic. That is very hard to come to grips. That's an important problem. How can a photon be in a horizontal polarization with only certain probability? Is it not? So that is that point. Then I think you have already come across, when you are talking something with respect to probabilities, you come across the probability distribution functions. You take the simplest example for understanding purposes. You say the object at a certain point at x equals 0, if an electron or particle is there, it is there only with a probability, some p. Then at -1, +1, -2, +2, etc., it has got a different probability. That means there's probability distribution function for the position of the particle. Okay. How do you get that probability distribution function? Is an important question. You have to go back to quantum mechanics and you know the wave function. You have to derive the wave function for that, all that environment, that potential distribution or whatever is given, you have to derive the wave function, psi. And then square of the psi is the probability distribution function. How do you get the psi? You will get from the different theories are there. Schrodinger's theory. For example, if you solve the Schrodinger equation, you get the distribution for the wave function. Okay. I suppose most of you are told about all this in this 6 months, 6 weeks, 6 days. You have studied quantum Schrodinger's theory or Dirac's theory, density matrix formulation. These are all the quantum mechanics that for the time being you can ignore. You just assume there is a probability distribution function and the average of that. When you talk about PDFs, you have the mean, standard deviation and all the other moments. So the mean of that represented by the ket notation is what we are thinking of as the position of the probable position of the object. Okay. And also there are a lot of other properties you have to derive from this wave function. Suppose you want to find out the momentum, you want to find out the polarization. Then according to the quantum theory, you need an operator. You take the operator, say for example H or L. Operate on this wave function, you get that particular average. Suppose average of the momentum. Momentum operator L, operator on the wave function, you get the average of the momentum. Similarly, many of the things. So this leads to the observable, idea of observable, whether we can observe that or not. Classically, we know if you want to measure some current in a circuit, you connect your ammeter or something, you can easily get a very good indicator of that. You cannot do that with a quantum circuit. Suppose you, hypothetically, you have a quantum circuit, you want to measure certain parameters like the polarization of a photon, you cannot measure. When you cannot connect a polarization measuring device like a polarizer and then say this is the polarization of this photon, because it is probabilistic. In fact, actually, from quantum point of view, we don't need to talk about the specific, I mean, you must have encountered the basis vectors, is it not? We need not talk in terms of basis vectors. Let me add it then. Horizontal polarization is one basis vector, vertical polarization is another basis vector, and any given object polarization can be set with a linear combination of these two. So we need not work out with respect to basis vectors also, but of course this is a very convenient thing. So what I am putting the object is measurable quantities. We cannot measure. Okay, so there are a lot of techniques to predict or assess what is actually happening. From some other outcomes, we have to do that. It's not like a measurement that we do in the classical. That's what I would like to impress upon them. So we need a little bit of mathematics. You must have already come across, is it not? All the ket notation and all the things you must have already used. All that is very useful. What I am urging all of you to do is put that equation on your paper and observe it for a long time and see what it is. That's what I would want to urge. Let us get going. From known knowledge to unknown thing we are going. Superposition, for example, is a known idea in wave phenomena. If there are two fields, E1 and E2, then the resulting field is E1 plus E2. That is the idea starting superposition. Even in mechanics, suppose there are two forces acting on a simple pendulum, one is gravity, one is some other force, then the resulting force is sum of these two. Not E1 square plus E2 square. That is where the linearity is coming into picture. We have, see, this also I would say, according to fundamental science, our mind has oriented towards linear systems. Our mind is oriented towards linear systems. But real world is not so. There are a lot of phenomena which are, for example, earthquakes or ocean waves. They are all non-linear phenomena, very interesting. You have to have real mathematics. Then, someone has told you quantum supremacy? That is the real reason why we should go for quantum systems. Okay? Quantum supremacy means that particular operation cannot be done with classical. It's impossible to do. Not exactly numerical. See, I think most of you have been given, we are told, a big computational problem. People said if you have 10 power 23 items, it's almost impossible to search. Is it not? That is a computational problem. If you are given sufficient power and sufficient time, you can solve that. But there are problems which cannot be solved. We'll give, actually it's not a real good example, but in the class we give an example of e power minus x square. Suppose I want to integrate e power minus x square dx. There is no closed form expression for that. You cannot integrate, there is no antiderivative. It's something like that. It's not a good example, but there are problems which you cannot solve by classical means, which can be solved by this quantum approach. That is what is called supremacy. Okay, we have to find out newer problems and impose to get at least somewhat semi-quantum, semi-classical that supremacy we had to use. Any example where the problem cannot be solved by classical means? A lot of problems are there in the real world which we cannot solve. What is that? No, I'm not able to get to it. They call it algorithms, somewhat semi. See, a lot of, I think computers you people know very well, a lot of things are there which cannot be cracked.
Because these algorithms require a lot of computation and they need some type of convergence for getting the optimal solution.
See, that is computational problem. You see, what he is mentioning, like what I mentioned earlier, complex problem is given and our computing power is not sufficient, supercomputers also, so we cannot solve it. That's what you say. Is it not a big problem?
And lots of operations are required for making
That is agreed. You are making more and more, you are giving a problem which is impossible to attack because of our basic limitations, not the fundamental limitations. For example, see, those who are computer science or in number theory, a lot of problems which are not. You see, for example, Fermat's theorem. I suppose many of you thought about number theories. A square plus b square equals c square. We know all the solutions. A cube plus b cube equals c cube. Most of a power n plus b power n equals c power n, or a1, a2, a3, so etc. So, in principle, people have proved it is the solution. There is no solution. Is it not? No, I am not relating it to the quantum. I am just saying that there are problems which we cannot solve. Okay. There are certain problems which quantum can solve, such things. That's what is the point here. You must have also seen this. The starting point is Feynman for, at least the present quantum education. Feynman is one of the earliest person to have recognized that we can use quantum phenomena for computation. Okay. At that time, no computers. Much earlier than this, is about 1980s or so when he first declared this. But he was there since long, and quantum mechanics also was there since long time. And people have recognized what is called quantum limits. There are quantum limits to most of the physical phenomena, like your CMOS gate width. See, in the electronics, what is the one fundamental limit? CMOS gate width we cannot reduce because of lithography, not fundamental limit. But if you go still smaller, the quantum limit comes. You cannot reduce it to more than certain value. That is called the quantum limit. The RC time constants and all these things are limited by the quantum limits. This timeline also you have seen, starting with 1980s to present day, a lot of developments have taken place in quantum. One or two points we want to highlight. We can say short. Now it is known thing. It is there in the papers in your, what is that? Did you, I think you must have already come across all these tools, is it, or QS kit?
This field, very late introduced. Some of the search was universal.
So a lot of tools are coming up now. Many universities and many people, they are throwing out.
Ideal platform we had in hands-on session.
Anyone has seen the computational tools by Apurva Patel? There's one professor, Apurva Patel, in IIC, in the high energy physics. Their lab has got a computational, quantum computational tool, software sort of thing you can say. So it's very good. It goes to the fundamentals, not just manipulation of numbers, etc. So he has been working on this subject for a very long time. In fact, when I was a student, I took his quantum computing course. I mean, we were working only recently on this, but that was about 20 years ago itself. The people, a lot of people, many students were taking the quantum computing by Apurva Patel. He is the head of all this national initiative. But he doesn't accept many things easily, including, of course, I am slightly lenient, but if you go to him, he will reject all your project easily. He will ask you all the questions and say, how is this coming and all that. I would suggest you please come to IIC sometime. They have built a big building called Interdisciplinary Center behind our EC department, and 7th floor in that building is dedicated to quantum computing.
Actually, we proposed the industry visit to IIC and quantum labs. But they gave the early we can schedule that we got the response from the IIC.
There is one problem I'll tell you, people. Existing quantum, you see, most of these algorithms, high performance systems and all only you can see. You cannot see. See, if you really want to visit a quantum lab, please go to Physical Research Lab, Ahmedabad. If possible. Professor R.P. Singh, they have got a big, about 4 times this room, all with optical systems, tables, lasers and all that. He can show you quantum entanglement or qubit states, non-linear phenomena and all that. That's very good, very nice, if you well motivated to study that. But as I said in the beginning, we want all these things to go onto a chip. How do they go is an important question. I will show you some slides later on. Okay, so one more. Searching big numbers. So if you want some such things, a few of our earlier students have worked on some complex algorithms using photonics. I'll show you later on. If necessary, I'll give their papers. Another important motivation for all our quantum is this one, this Chinese Meteus 1 satellite. You are aware about that, is it not? 2016, they have launched this Meteus 1 satellite and transmitted QKD information from China to Austria in Europe to 1,200 kilometers, satellite communications. Light waves, free space optical communication. So that is one which has prompted all over the world to the present state that we have. Indian government also woke up and they made a big meeting in IIC, including all the people from defense labs, IITs, etc. and said, let us do something in quantum. That is a starting point. They said, we are now allotting immediately 500 crores. Whoever wants to do some quantum related work, please come forward to do and propose projects and all that. A few we have proposed, like Anurag in Hyderabad and Allahabad, that lab. So they have done that. But still, at this moment, if you see the scenario in India, still we are not much ahead. Chinese are, of course, definitely far ahead. And many other countries, like European countries, they have. You really have to go to a good conference on quantum. See, I hope many of you know Quantum Week. Every year they conduct IEEE Computer Society will conduct a quantum week.
September 1st to September 5th.
Yes,
And we conducted
you are conducted.
you are part of the
I know. I see. I am talking. See, what all he is saying is correct. We are doing this FDP 1 week is there and all that. See, what I am saying is that is called a quantum week. IEEE quantum week. The real stuff you can observe there only, not in all our FDPs. Okay? I was just, that's why I was asking whether, see, these are all useful information. You go back and reflect. This in different places, like Canada, last time it was in Canada, then somewhere in Abu Dhabi or so once it held. See, I hope many of you know these conferences, Globecom. Anyone familiar? Which is the top conference? See, I am communication person. I don't know too much about computer related conferences. Which is the top conference in India for communication people? Whatever it is. Globecom is global. Agreed that you know that. I know. Very nice that you know. There is what is called NCC, National Conference on Communications. Okay, I think next time in February in IIT Kanpur. Top conference in India. What he said is correct. Globecom is the top conference globally conducted by IEEE Communication Society. So if you want to really know what is latest happening in communications, you should go to that. There are a lot of conferences like that, important ones. Networking, protocols, wireless, then high performance. So many conferences are there. I suppose, let me ask you, even though it may not be a waste of time, I'll give you a lot of stronger information on photonics, but I want to ask you all this. I would like to know how many are computer science, members of IEEE Computer Society. Anyone in this group? Very good. He is there in many societies, I know. See, one important thing, of course, I will be happy. I am very happy that he is Computer Society member. I would like to suggest everyone, pick up your area of interest and join that only. Don't get lured by other groups. Suppose you are interested in quantum computing. See, which is the society? See, I suppose many of you know, is it not? I have no constraint about the time. I have a lot of slides also. Got a lot of things I can show you. So, let's some 10 minutes. Let us debate on the professional aspect of this. So, you are interested in compute. Let me say quickly, the very good input for your FDP. I suppose many of you are interested in quantum now. You are interested in quantum algorithms, quantum systems, fundamentals, then implementation issues, then using some tools. Tools, of course, everyone has to use, including some normal Python or MATLAB and so on. Someone is familiar with Mathematica? Anyone has used Mathematica? It is a rival to MATLAB actually. It's not so popular as MATLAB. See, what is the advantage? Nowadays we can do in MATLAB also. You can do operational calculus. In Mathematica, we used to do operational calculus. That means you can operate on some function and get another function. Like for example, I want to integrate, still very small example, let me take, integral sin x dx. Most of the time we can do only numerical calculation. It should give out cos x as the output. Anyone has done that? Suppose a plus b whole to the power of 10, I want to expand. It must give a power 10 plus 10 into a power 9 into b, etc., etc. That also is giving nowadays. Anyone has tried that? So we have to do operational calculus, transformations. You give a Fourier transform of x into e power minus x. F, it gives you the Fourier transform of that. Yeah. A lot of quantum information you can use this. And I mean, of course, if possible, you can, if you are versed with some of these, even in Python, people have been doing, our students are there who are doing also. You can create your own toolbox. See, IBM, QS kit and all the standard things they have put there. Particularly if you want to do research, See, if you want, there's one important problem. Some of you want to do research in this subject. We cannot depend on the software tools. What all is there inside the tool is old. Research means you have to do something new, no one has done. So that is not sufficient. For understanding, for learning into the subject and for classwork, it's okay. Okay? So all this please keep in mind. I'm randomly speaking. We'll have to do all these things if you are interested. And I would suggest you please form a small group. In under IEEE also we do that. And then keep discussing and spend some time basically. See, that's what I'm interested. Okay? So let us get going. I'll show you a lot of these things as we go along. This also I suppose you know. Anything which is odd, you highlight, I will tell. This you are familiar, is it not? The resolving the qubit state into horizontal and vertical. Basis vectors. Suppose you have basis vector, or I'll take the, because this is optics, we'll take the example of photon. So you take an arbitrary photon, it is in arbitrary and polarization. It is there in some polarization state, 45 degrees or 60 degrees, etc. And I said we don't know what is its actual state. Whatever it is, you can resolve into horizontal and vertical polarizations. And then a linear combination of these two is the actual polarization. Alpha into 0 ket plus beta into 1 ket. That's what you have learnt the way. 0 ket is the basis vector for horizontal polarization, 1 ket is the basis vector for vertical polarization. You can also say mathematically 0, 1 and 1, 0. You can put it in the matrix form. So you will get the actual state of the photon. Okay, that's what you have already done. Similarly, if you want to extend it to multiple qubits, multiple states, not exactly multiple qubits, multiple states. Suppose 4 levels, D1, D2, D3, D4 are the possible basis states. Say, let me say 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, etc. 4 basis states. You can express psi as a linear combination of all these 4. Alpha 1 into, I think some slide must be there. Yeah, okay. Something like this. You require, suppose, just as an example, as to understand, suppose 2 qubit state you are talking about, that means 4 possibilities are there. Basis, for the basis. So, first photon and second photon, linearly independent, each can be in its own state, and 2 PDFs, one for this and one for this, and 2 bases, 0 ket plus 1 ket, 0 ket plus 1 ket for this, combination of all this, 0, 0, 0, 1, 1, 0, 1, 1, joint PDF, is it not? Joint PDF and 4 bases, 0, 0 ket, 0, 1 ket, 1, 0 ket and 1, 1 ket. Matrix form 0, 0, 0, 1, 0, 0, 1, 0, etc. And alpha 1, alpha 2, alpha 3, alpha 4 are the coefficients. I suppose you may not have done. Anyone introduce you to Hilbert spaces? You need good mathematics of Hilbert spaces to do all these things. For the time being, we'll simply say these are complex variables. Alpha 1, alpha 2, alpha 3, alpha 4, complex variables. Why complex? That wave function is coming out to be complex. The Schrodinger's equation has got coefficients which are complex. I into H cross you come across. Schrodinger's equation everyone knows or not? I into H cross is there. That means the coefficient itself is complex. That means the resulting psi is a really complex function. Okay? And then the square of that is the PDF, that is real function. So the conclusion is that alpha 1 to alpha 4 can be complex numbers. That is the root cause for resulting in so many possibilities for the quantum state. Qubit state can be anywhere on that Bloch sphere. For 2D, for 2 qubit state, one single qubit example, you can have a Bloch sphere on which the psi can lie, and so all possibilities are there. infinite possibilities represented by 2 basis vectors. That's all. Here you have 4 basis vectors. So when people try to approximately estimate the complexity of computation that is possible, if you have a 2-qubit system, 4 basis vectors. If you have n qubit system, 2 power n basis vectors. So the complexity is scaling as 2 power n. Okay, that's the argument.
So is there a limit for reducing the complexity of the system out to the order of, because as the number of bits are increasing, we are increasing the complexity by 2 power n.
Yes.
Is there a limit which can be used for
Reducing.
reducing the complexity?
See, actually the idea is you don't reduce, use less number of qubits.
But if we use this number of qubits, there will be chances that the power energy will be more. And again, it may lead into the entanglement and we may not be getting that results.
That is better. Suppose there are 3 photons. They interact. Suppose there are only 2 photons. Interaction is less. Suppose n qubit system. N objects we need. Is it not? Suppose you want to build n qubit system. N photons you need. Suppose I want 64 bit computer or operation. What can you do? You can do only with 5 qubit system. See, in electronics we are not using that. It is possible. It is there. Actually, in coding theory and so on, interaction is there across all the bits. Whereas only 5 qubits you can do 64 bit things that you are doing in classical. So that's how what people say scaling in a complex way, in exponential way. Okay. So instead of having a 64 bit classical computer, you can have 5 qubit quantum computer. Very rough estimate. If someone is really interested to know the theory of this quantum information, you should look at one seminal paper by Shor, Bennett and Shor. Anyone is familiar with that paper? Quantum information theory, IEEE transactions on information theory, around 1996. See, I would say at the end of this FDP, if you are able to understand that paper, that is more than sufficient. Anyone knows that paper? I'll give you, otherwise. Bennett and Shor, quantum information theory. Okay, I should not tell you too many stories. Let us get going. You see, maybe just a minute. See, what is the basic thing that you must have been familiar? Bloch sphere, and all the points on Bloch sphere are possible qubit states and all that. There are a lot of possibilities. Like, for example, this 0 ket plus 1 ket by 2 is not in the classical domain. Output y1, y2. You need not to worry about taking notes and all. In our class also, regular class also, we don't encourage students to, because we are talking randomly. I'm not doing systematic. Some lecturers, of course, in many of your classes, you have to go systematically, because students are oriented, mind is oriented like that. They don't explore themselves. So you have to go in a systematic way. When you are learning, we have urge to learn something not in a linear fashion. For example, when you are studying the qubits, suddenly you want to know what is this polarization. You skip there and then go to third chapter or so to see what it is. You learn. See, I would suggest everyone has got their own way to learn. We should encourage that. At least when you are not forced, or when something is not imposed on us, when your mind is free, you learn the most free way that you want and take the best resources. Okay. I hope you have also come across Hadamard gate, which is a linear combination of 0 ket state and 1 state. I will show you how that is implemented. This is one of our earliest paper, how to implement Hadamard gate using optical waveguides. So these are also, all these things also you have already come across, I suppose. A CNOT gate will require 4x4 matrix. Double CNOT gate will require 8x8 matrix to represent. And you can easily work out. See, for example, the C is controlled by the first 4 elements. When this is identity matrix, you can easily see this identity matrix. T is same as So these are all the pictures for representing various types of gates. You must also come across DiVincenzo, is it not? DiVincenzo is not done? This is one of the earliest papers in quantum which demanded what are the requirements for a quantum computer. See, this is called, what is that? Physical implementation of quantum computation. See, in some German, see, we are always English papers, but almost in 2000. So you need, if you want to build a quantum computer, you need this. These are the demands. Each one of them is well described. In this paper, each one is a separate section. You need to have a scalable system. If you come out with an idea of some 4 qubit operations, like all those matrices, etc., then we should be easily be able to extend it to n qubit systems. Scaling is an important property. If you're not able to scale, that will be constrained. It's very difficult to go for more complex algorithms. You must be able to initialize the state of the qubits. What is meant by initializing? We don't know what state the actual qubit is. But we want to predict what it can become. Just as an argument, suppose you send all the qubits through a certain set of gates. Then you can say the probable state of the output state is ready for computation. For example, all qubits you pass through a polarizer. What does it do? It will reduce to, say for example, all to horizontal polarization. Some of them will be half, some of them will be 1/4, and so on and so forth. You get a sequence of numbers for each of these states. That is what is the preparation to start with, initializing the state. Decoherence, you have come across? I will always ask him. Decoherence.
Decoherence,
See, what happens is the qubit state is not permanent. With the time, with space, etc., etc., it loses its character. For example, if I talk about 45-degree polarization photon, it doesn't remain 45 due to whatever reason. We assign a random reason for that. Randomly, it will change the state. And sometimes two parameters we know, space and time. After a certain time, it will reduce. We say it decoheres. Actually, the idea of coherence is acting together. See, I don't know whether I have not mentioned, these are all bosons. Photons come under a category of particles called bosons. They will not follow the Fermi-Dirac statistics that we are familiar with in electronics. So there what happens if the more and more particles can be in the same state. That is the coherence. Laser beam. Yes. See, suppose there are 4 photons. They are more and more likely to be in the same state. If there are 4 electrons, each one will have a different state. One in the half spin, one in the down spin, one with some other angular momentum. So each one has a distinct state. Whereas more and more photons, that's how you build lasers. Laser is a very coherent beam, you call it. That means all the particles are in identical state. So if you do some operations with all these things, they will decohere. Is more natural to decohere than together. If you don't disturb them, they will decohere. So you talk about decoherence types of fractions of a femtosecond or picoseconds or so. Sometimes long decoherence times also. It is good to have good decoherence times. And also space. If you are transmitting from one point to the other also, after a certain length, it's not the same coherent state. Then people are still debating on what can be the universal set of gates. In electronics, you have NAND gates performing most of the logic functions, memory operations, and so on and so forth. You can realize all other things by using some NAND gate like thing. So which is a set of universal gates for quantum computing is still a point, but if you have seen QSKit and all, for example C0 or some other gates can be configured to do almost many operations that we are familiar. But as you know, there are many other possibilities in quantum. We have already seen on the block sphere, etc. So all cannot be easily met by some simple NAND gate or CNOT gate. So still people are thinking what can be the more.
With respect to codes, states and codes.
Yes.
So what would be justified for station like bits?
See, flying qubits means with respect to space. As the photons or these particles are moving, with space they decohere. For example, light wave, it diffuses or disperses. So that will be a reason for decoherence. So we need spatially coherent photons.
When limits have the coherence limit, can it be stationary?
Yes. See, suppose we want to confine the photon only to a small region of space. Suppose you are talking about a quantum chip in which it stays almost the same place. At the same point, you do the operations, etc., without moving. Then that spatial coherence, that flying nature is not there for that. So you need to worry about temporal coherence. Whereas if you are doing a communication from, on the chip also, we want to move photons from this point to this point. Then spatial coherence, that you can once again call them flying qubits only. Okay, so both spatial coherence, temporal coherence, both are important. Then this is one of the earliest seminal papers by DiVincenzo that discusses all these properties, what is that and how it is necessary and so on and so forth.
Can give the break. Yes.
Okay. See, I am available here. We can discuss. I don't take tea or coffee. I'll take some water like this. Okay. See, there's one offering for you people. They are from different colleges, is it not?
Different colleges.
See, if you are this subject for professionally, if you are interested in quantum, your other faculty members or students, you can form certain IEEE chapters in your college which will orient towards this subject, including
So it's talking about IEEE.
we are interested in quantum right now. I'm not talking about everything. That also you ask me, I'll tell you. There are 39 societies in IEEE. I suppose many of you know. Some of you are members in some societies. If you want to deal with this quantum, there are certain societies which are oriented towards this, like IEEE Computer Society. There is a society called Computational Intelligence that will combine AI also.
We recently inaugurated the society.
CIS.
CIS.
Then, most prominently, not only for quantum, you have the IEEE Photonic Society. That's more physical also, you can say lasers. So if anyone want to join these, or if you want to take open a chapter in your college, you ask me, we can do it. Okay? I would suggest by the end of this today's FDP, a few of you please join IEEE Photonic Society. And this is an offer for you. If anyone is joining today, we can take you as an EXICOM member in IEEE Photonic Society Bangalore chapter. Today, it will cost about $100. It is about $100. IEEE membership roughly $87 or so basic membership. Some $10 for photonics, or ComSoc is 16. Computer Society is still larger, 25 or so. And GST, it comes to 118 or something like that. See, I would say actually, I know that is a large number, unless someone supports. It's very difficult to meet such a thing. But if you are really interested in quantum, etc., no futuristic thing, definitely we should. At least a few in a college, 3 or 4 members should be there. One in ComSoc, one in photonics, one in CIS, etc. Then, see, we will in Bangalore section, IEEE Bangalore section, we are trying to make a program where you can form a small quantum interest group. And all the papers are there, whatever you want. I have mentioned also. Going, okay. So most of you must have now familiar with the architecture of a quantum computer. How is it different from a classical is the important question. But I'm not addressing that part. But what people do, like in any other computer architecture, or for example, you have this 7-layer OSI model for internet operations. They divide into layers. Starting with the physical layer up to the application that you are interested. So most of the time, I think in all these, whatever you have learned until now, they must have ignored little bit the physical part. So at the network layer or at a certain layer, so layer you can call it as computer operations. You have come across this word device independent. A lot of operations are said to be device independent, whether you use optical techniques or electronic techniques or qubit superconducting, it doesn't matter. It's a block. That's what most of the software tools also do. They will assume device independent operations. Because if you bring in device, all the other properties like the decoherence and all those things will come into picture, the physical level things. So they like a noise in communication systems. In many of the in the beginning stages of communication, you ignore noise and then calculate all the other things. Is it not? Similarly, you divide all these things into several layers, and each layer you more and more complexity you add. Actually, it is other way also. As you go from top to bottom, also the complexity may change from middle to up, and so on and so forth. So the layer approach is the most common thing, and also this is put in the notation. This slide is not very clear, even though I am using PPT. So you design flow goes like this. I want to conceptual part, if it is there, I'll try to highlight. For the communication, what you have to do? Properties like an optical fiber, typical channel that is popularly used is the optical fiber. If you want to have a long distance quantum communication on the backbone, national backbone network, you can use. Actually, I suppose many of you know that a lot of fiber is dark. Whatever is there laid outside, some of them are empty. Nothing is going on there. Most likely people will use that for new communication modes in the future. Then noise. Noise has got a different flavor in quantum. Not only classical quantum noise, what we call as in detectors and all, we have quantum noise, is it not? The arrival of photons follows a certain distribution. And also the photon properties themselves have their own distribution. So noise has got a different flavor in quantum. I suppose anyone has, I'm assuming, I have observed some other FDPs, you don't do mathematically all these things. That's why we are shielded. You see, like earlier I talked about layered operations, is it not? Many of our learnings also, you ignore the most of this physical, equally important thing we ignore. We should go small steps in mathematical detail, then we'll understand better. Okay, I suppose many of you have come across, just a minute, this. I was told that someone has told you about BB84 protocol. This is one of the earliest protocols in quantum communications. And I have simplified this. I think it is already there. I have simplified it to only two bases. I mean, in this example, I'm assuming Alice has got two options, horizontal vertical minus 45 plus 45. And the way in this protocol, as you know, they choose randomly. The basis is chosen randomly. Maybe conventional, we see, I don't want to bring in new words, conventional randomness. They let them toss a coin and then decide whether to go with the first basis or second basis. Okay? And that is taken randomly. And on the other side, Bob also in options, combinations. 0 qubit is sent, horizontal basis is chosen by Alice, vertical basis is chosen by Bob, and detected qubits with so and so value. So like that you have to make a table like this. As 0 state, which is not correct. Similarly, next qubit, and so on. Vertical, horizontal, one is same, so it is correct entry. See, we are following the table. If this is sent, what happens? So when the actual qubits are sent, they will use this table to say this is what is sent. So you can, if you observe, 50% are not valid in BB84 protocol because you are choosing equal probability for first basis or second basis, both by receiver and transmitter. The number of entries which are valid in that lookup table is 50%. That's what you have, must have, I mean the conclusion that has been told to you, I think, in the BB84 protocol. There are a lot of variations are there, I was told also, you have learnt in this. So if you can easily work out if there is Eve trying to interrupt this communication, what happens to this table. Once again, you have to, let us assume Eve also understands what these people are trying to do, and then she will get 4 machines, horizontal, vertical for transmission, reception, horizontal, vertical for, once again, retransmission. So you have to work out a 32-bit table. But what you will observe, if you work out all these combinations, 25% only will be valid between Bob and Alice. That means immediately it is clear that someone has interrupted. That is the protection or security available with the BB84 protocol. The crux of the problem is we have to trace each qubit passing through which basis state, through including Eve and so on. That much is all right, or I suppose this is a free space communication link and very crude way, just for explanation purposes. You can use it in the classwork also like this, and you can make the variations to work out probabilities and so on. Suppose I say Alice and Bob will choose 90% of the time, suppose she chooses horizontal, vertical, and 10% only, plus 45 minus 45, you can work out what is the probability of correct detection. These are all things that you can do. I suppose many of you have seen this picture, Nicias 1 satellite by Chinese, which has spurred the interest in quantum. And then they are launching, they are more, see, you can say, if you look at the current literature or conferences that are happening, a lot of advances are taking place and these people are quite ahead, you can say. See, in India, a lot of interest is there, I agree. But we have to work towards some of these, even smaller, whatever algorithm or calculations that we do, we should be able to publish and say that we are also, see, if you look at our publications in this subject also, we are not in a comfortable position globally. You people who have interest in these should take the crux of the problem. You should go to the correct literature. Suppose you take some noise in quantum communication or some such problem, you go to the real, what everyone is doing, including Chinese, Europeans, and see what we can do better than them. Then you will get a good papers. Many times what is happening is because of the availability of tools, and also because, you see, many of our students and many of us are good at mathematics. So what you do is you do very good analysis and come out with certain results and publish. But you should compare where we can publish our work. We should publish in some top journals. Then only it will have good recognition. If you publish in next level journals, of course it will be counted in your thesis or so, but not sufficient. No one will read that. Is it not? I always ask the question. We get a lot of theses for corrections and so on. They publish. Paper is good, agreed. That is not a problem. But this is not recognized, well recognized. Even Springer elsewhere also. But of course, I know the other problem. If you send it to IEEE or some such journal, it will take very long time. Sometimes there is a lot of load on those journals. They will send back quickly. Rejections also more. These are all the difficulties. But we should try. In particular, of course, it is costly, I said. It's much more costlier to go to a good conference like Globecom or something like that. Okay? You people have thought about that or not? Someone should fund you also, your colleges or some, partially at least. Suppose registration fees you bear or some other travel grant they should give, like that. So what I mean to say is, independent of difficulties that we have, we need to put our hand globally. Then only a lot of things are valid. So let us go to a few examples, I will say. I suppose anyone has touched upon quantum internet in this FDP? No one has talked about that, quantum internet? There's a big subject. It's very beginning. Someone want to do research, very fertile area. There's one girl in our lab working on this, of course, very beginning. You can be in touch with us. And one of my past students has written a book chapter on this quantum internet. We can give you all that. Very interesting problem, because see, what is the main problem in internet or networking? Networking, let us say, it is not point to point. And then we said this quantum state is not known. You cannot copy. In a broadcast scenario, what we do, we send this information to all the users, and then the user will pick up based on the header information or something, whether the information is for that particular user. Okay, this we cannot do in quantum. Suppose your clients, suppose point A is there, B and C, the information has to be distributed. The qubit states will go to only B or C, not for both. So you cannot broadcast. But then what happens? See, how do we do? You, just as the example, suppose I say a splitter which will divide the information. Classically, the information into two users. In quantum, what it should do, it should divide the probabilities. Probability of information being at B is something, probability of information being at C is something, but not both. So if you have a bigger network, the probabilities are still diluted. You have to come out with a mechanism where you should say this information is there with B or C or something like that. So you need a different sort of algorithms to say, to predict what is happening on the network. That is the important problem here. So some companies like Samsung are interested in this quantum internet type of problems. I don't have much information on this. Of course, we didn't do also much work on this subject. So this actually what I wanted to show you much of it, if you are able to, if you want to appreciate. Okay. So this is the real crux in the near future for quantum computing. So we call it integrated photonics. This is called integrated photonics, not in bulk. So most of the present day photonics technology is based on silicon because of VLSI. All the lithography and all the operations, diffusion, electron beam, etc. are all available in silicon, well understood. In India also, a lot of companies are coming up, many of you are familiar. Semiconductor industry will grow dramatically in the next 5 years or so. There's a lot of opportunity for us to work on VLSI related problems, okay, including quantum. You can implement some of them using silicon VLSI or silicon photonics. But then, if you want to use photonics, the future is 3-5. We want active devices. Suppose you want to make a laser on a chip. We cannot make on silicon. You have to go to, all these papers are there. The slides also are given to you, don't worry. So, we have to go for 3-5. Gallium arsenide, indium phosphide, and all the alloys and combinations. Intermediately, what we do is we use crystals like lithium niobate, lithium tantalate, etc. to make some. See, these are called dynamic devices. Lithium niobate, etc. are called dynamic devices. You can change the properties. You can apply voltages, etc. to change. For example, if you want to make a high-speed modulator, commercial available is on lithium niobate. Other option, as you know, is laser diode. You can directly modulate to whatever speeds you want, up to some 5 gigahertz or 2.5 gigahertz. Whereas in lithium niobate, you can go for much higher, 10 or 20 GBps. You can easily modulate on. So these can be called as intermediate technologies. Crystals and some of these are already, they are playing a big role in other domains like imaging and so on and so forth. But ultimately we want 3.5. And also one more technology that people are trying to do is use the existing VLSI silicon technology but grow additional layers. Someone is VLSI persons in this group? Any VLSI people? See, nitride is the next important material on silicon. You can grow nitride on silicon and then it has got high K. So all the devices will shrink. That is the idea in nitride. Similarly, in optics, in photonics, people are going this lithium niobate on silicon. You can grow crystals. See the class matching and all problems you have to solve. But you can coat electro-optic materials on silicon. Then what happens? You can change the properties. See, I think I don't know whether I have a slide or not. If you want to make a high-speed modulator, you put an electrode on top of this waveguide, optical waveguide, apply voltages, RF. You can go up to 10 Gbps easily. And then the phase of the light wave is modified. So you have a good optical modulator with this electro-optic effect. Okay. Then extending on to this, on the chip, we want to modulate this light wave with your qubit states. Light wave means many, many photons, full wave, so many milliwatts, fraction of microwatts or milliwatts. This modulating information is quantum. How do you modulate? I'll show you maybe. I think it's better to show you lithium niobate modulator. I may not be able to tell you how it is modulated right now, but we can see how we are conventionally. High-speed optical modulator means what it happens. So some more pictures I'll show you about how they look like, some devices. Suppose you want to do generate and manipulate qubits, photonic qubits, let us call it. How do you do? This is an example. You have a grating coupler. Gratings are an important devices in optics. Okay? Grating means a periodic variation of that refractive index. Refractive index is the fundamental element, fundamental parameter, you can say. If you change the refractive index, you can change the properties of light propagation. Okay, just that much is okay for now. So we use a grating coupler. See this, you see whatever is showing, it is shown like this, but you are not able to make out that they are periodically varying. Some places, it may be like this. Let me give this as example. Here you have high refractive index, low refractive index, high refractive index, low refractive index, etc. This is called a grating, Bragg grating. Okay, so if you pass light through this, some particular light will be reflected, some particular light is transmitted. That depends on this grating pitch. Okay, gratings have got what is called your pitch. So in this particular case, some light is getting reflected here. These two photons, see, this is in this application, in this paper, they are sending photons, not simply light waves. Okay. So these two, they want to split red and blue. Red is called the idler. That means it is slightly higher power photon compared to this blue. And then blue you want to resonate. This is a resonator called a ring resonator. Okay, different radius 6.55 and 6.5, very close. Okay, so this will split blue photon into this port and red photon into this port. So you can manipulate the signals. You can generate, say, single photon. You can isolate by using such a mechanism. In this is a tuner, whatever frequency you want, but very close, the resonant frequency of these is very close for both red and blue photon. And so this will go through this. This is a full wave, you can say. This green one is a full wave. And all the extra thing other than this red and blue photon, you have to reflect back. This is a big, see, this is a basic question that we have. I want a single photon. Qubit states are worked with a single photon. But we have to transmit several kilowatts of power from ground station to the satellite. How is this qubit information embedded inside this is the question. Okay? This is a example showing how it can be separated out. If you get a full wave like this, green, which contains these two also, this resonant phenomena will generate this. And the entire thing is passed through this. So you can separate out these two. Instead of showing only one photon, two photons are shown here. One is idler and one is this. So these are all the type of devices that you will encounter in photonics. We can do some of these in our lab also. You can fabricate a ring resonator, you can fabricate a grating. Gratings are popular in other domains also. Some of you, if you are interested in sensors, like people use for health monitoring of aircraft and some of the structures, you can embed these sensors inside aircraft wing and monitor whether there are strange temperature variations, all that. So that's where the popular domain of this FBGs, that's a very popular subject. So if someone wants to work on sensors, it's not very difficult. At the college level also, you can set up a small fiber optics lab where you can work on some sensors, pressure sensors, blood pressure monitoring you can do on the surface. You need not embed it inside the body also. So all these areas you can work. That's another domain of photonics, fiber optic sensors. So this is another example of manipulation, generation of photons by using what are called these coils. These are fiber arrays. You can assume or consider for this slide, these are arrays. A fiber is put in the form of a coil like this. This is a blown up version of that. So what is the purpose of that? It can delay photons. Suppose you have 1 kilometer of fiber. You can calculate how many microseconds or nanoseconds the photon is delayed. If you delay a photon and superpose with another photon, due to the phase difference, you can know all the properties of that photon. I mean, when I say we know with a probability, okay, that is assumed. So there are other components here. There are, I mean, just I will mention, I will not say what they will do. There are couplers here. Some of these can be made because we are talking about integrated. This may not be possible, this coil may not be possible to be made on a chip. Whereas from this point onwards, even coupler and all this is an interferometer, all this can be made on the chip. So many people are interested to, lot of activity, work goes on in generation and manipulation of single photons. So earlier that was on the external to the laser. Here you can create a laser along with all the single qubit properties. So one more slide I will show you on some other detection side also. Much more better improvements have taken place on this detection side. High speed detection is already somewhat familiar in fiber optic communications. You can detect, say for example, 30 photons or 50 photons. If they are there in a incoming light wave, we can detect. See, a lot of instruments are there, like spectrum analyzers, then BR measurement equipment. They can measure up to some few photons, not single photon. If you want to detect single photons, you have to have an alternative mechanisms. Say for example, in the bulk optics, what they do is they reduce the intensity to a certain level so that you get, what is that called? Multiplication only for a few photons. When a photon falls on the photodetector, it will create electron hole pairs. That is called avalanche process. You can multiply the number of electron hole pairs detected. So this is somewhat slightly better, you can say, compared to generation of photons technologically. So people have also done full QKD on the chip. And also you can also, I mean, anyone of you, if you are working on some of these QKD problems, you can estimate what is the probability of correct detection, what is the probability of error, and so on and so forth, assuming that all these devices are on the chip. So some names are given here, what all you will need. So I'll show you one more. I want maybe very simple one I can show you. I want to maybe later on. See, if you are interested, I'll show you another set of slides for photonics alone without quantum. Teleportation is a very interesting problem. This is on the chip. You can say someone is trying to do like almost equivalent to teleportation on the chip. So one more slide I'll show you about work. These are all the topics that we have worked in the recent times. Cryptography, then a few algorithms like Google PageRank and quantum box, etc. Our students have worked. Not much experiment. Recently only we are trying to do some fabrication and experiment on this. These are one of the other recent, I suppose some of you may be interested in this. Higher dimensional key distribution. Instead of having 2 qubit states, you can have 4 or 8 qubit states. D1, D2, D3, D4. And then the actual state psi is a linear combination of all these things. So you have d power n. Suppose you have n qubits. They call it qubits. D1, D2, D3, D4. Then d power n. Instead of 2 power n, you have d power n growth. Then we worked on some of this actually, just not very experimental. Recently we are trying to do the modes of optical waveguides. I'll show you one picture maybe. And also when the student is interested in angular momentum, instead of using polarization, you can use angular momentum of photon to represent the qubit states. That's a very hot subject. This is one of our earliest paper on this subject. So I want to show you this picture. See, because it is a mostly your quantum FDP. I don't want to put too much photonics. See, in one of our recent papers, what we did was, this is called a Y branch. Okay, top view. You can make it on a chip like silicon or glass or lithium bit. And this width of the waveguide is important. If you make the width to be some, say 2 microns or something like that, then it can propagate only one mode. Like fiber optics, many of you are familiar with fiber optics. You can design a single mode optical fiber. Okay. See, you can manipulate, if someone is, I think many of you are from ECE background also, the V number of an optical fiber. If it is less than pi, then you have a single mode fiber. Not pi, 2.404. Okay. The first zero of the Bessel function. If V number is less than 2.404, then it is a single mode fiber. Only one mode can propagate. In this case, because we are talking about waveguides, if V number is less than pi, you have only one mode. If V number is less than 2 pi, you have 2 modes. So we designed 2 mode waveguides. First one called T0 mode and next one TM1 mode. First one can represent 0 qubit state, second one can represent 1 qubit state. Instead of using polarization, we can use modes. It's very easy to design. In the free space, you have a difficulty to do this. Another advantage of this approach is, I can very easily design 4 mode waveguide. Suppose I make the waveguide width to be some 6 microns. Then it will propagate 4 modes. And then, of course, their betas are different. There is a difficulty. Okay, that's a different problem. 4 modes can propagate. In this example, 2 modes. And then this junction, conventionally what will it do? It will divide the power. Half a milliwatt of power here and half a milliwatt of power here. And if you launch a single photon, either in this state or in this state with certain probability, what happens? It can split the modes. Mode splitting action can happen. And then if you observe the overall picture, you can say that output is either 0 plus 1 ket or 0 minus 1 ket. This you recognize as a Hadamard operation, is it not? Linear combination of the 0 qubit state and 1 qubit state can result from a very simple object like this Y branch. Idea is not very complicated. If you are using a beam, I suppose if you are in optics, for example, a beam splitter will divide the power into one direction and the 90 degrees direction. So exactly like that, we have translated that idea into a waveguide problem. Similarly, You can also create 1/4 splitter or a directional coupler, etc. If you are interested, I can show you that. And that is the way that we implement. These are called photonic band gap structures. You make a periodic structure on a silicon wafer and you can create defects. Like in semiconductors, you can call this as the defect, line defect. See, suppose if these are smaller compared to other holes, then you can call it as a line defect. So you can make a Y branch by using line defects. That will be very compact. This will not be compact. This will be very thin and long. That's a difficulty. In the recent times, we are using that technology for that. This is called photonic crystals or photonic band gap structures. So this will be worked out once. What is the efficiency? What are the problems, and so on and so forth. This is also one of the earlier papers only. So Mr. Rohit, he just recently finished his thesis. He has also worked out if you want to build a BB84 protocol on the chip, what are the efficiencies that are possible and all those things. And also extended it to qubits also. Higher dimensional qubits if you want to use the BB84 protocol and translate onto a chip, what are the difficulties. So this is another work by Varun Raghunathan in our department. They are trying to generate single photons using similar techniques. You have a ring resonator coupled to a bus waveguide and you have a pump and all that, and you can generate very nicely these single qubits. And also you can dope. It's also not exactly on the lithium bit. You can dope on silicon also you can do. And other materials like nitrides and rare earth elements you can dope to make the different levels. For example, you can choose this energy band according to the materials that you want. So I will show you another set of slides if you are interested. I have one, that's not quantum, but photonics if you want, I can show you more. So these are all many of our students and our faculty members in our department. Associated with our lab, you can see. So if you are interested, I can show you some of these theses. This one fellow, one of my earliest students, he worked on algorithmic aspects of all this long ago, 2015, before Chinese. This thing he has worked on quantum algorithms, and some of his papers are there here. Where is that? Where is it reflecting? Is it? Yeah, because of the low battery also. We are. Yeah. She has also worked on very good paper she has got on quantum cryptography, then random number generation, all those things using photonic devices. Then any other point I want to highlight her work. So this fellow had worked on combining your machine learning techniques with photonics. Little bit of quantum also. For example, Google PageRank. That is considered one of the benchmarks, is it not? If you want to evaluate an algorithm, you apply it to Google PageRank. So he has done on this. And also one example of a neural network. He tried to evaluate how it works on optical domain and so on. So I think I have given randomly some information, but if you are interested, there's a lot of information with me on all these papers. Then photonics we have about 10 times than what we are doing in quantum. Quantum only recently few theses we did. Recently, see, our main interest is on the integrated optics. on the chip devices. Maybe I think I should show that I have, maybe to interest some people. See, that is a very simpler thing that you can actually do. See, the photonics on the chip, even theory for that matter, is the easiest thing that people can do. You take a simple like that Y branch I showed you. You can easily work out many things. See, there's another device called there are certain basic devices in photonics like directional coupler or a waveguide or multi-layer structure. You can easily apply these to quantum operations. Almost very little work has gone in on integrated photonic devices. Many of them they are fabricating. See, some big universities and companies, they are fabricating this. A lot of work goes on in qubit sources, photo detectors, high speed quantum and all that. But not on the quantum functionalities. Suppose you want to implement NAND gate on the chip. What is to be done is not done. If you look at literature, quantum NAND gate, you will get very few papers on the integrated side. That's where a lot of potential is there for those who want to work. So that is the reason I said I can give you a little bit, very crudely, some 10 minutes I'll give on photonics. Let him launch the other set and then we'll conclude.
Sir, how can we implement this basic gates in the hardware? Is there any opportunities being done?
See, actually, unlike the usual things, if you are interested in fabricating some things, not only quantum, some sensors or communication devices, if you want to fabricate, you can do that. One source closer for all of you is, you can come to our Nano Center, Center for Nanoscience and Engineering. Not only photonics, many things like metamaterials or antennas, etc. you can fabricate in our fab center. There is also facilities for measurement. Characterization also is there. I suppose some of you can visit the Nano Center to see what are the facilities that are available. One additional input for you is, they will be happy to, you are welcome to come and fabricate there. If you say that you are really interested in this, you have certain projects or some problem to solve, etc., you can come there and fabricate. And there are national programs like NPMAS, National Program on Smart Materials. They will fund you also certain small amount. And then for very low cost, very little cost, they will allow you to fabricate there. Suppose some research scholar you have. Suppose he or she wants to work on some sensor or some such device. So they can stay there for 1 week or 2 weeks, fabricate these, and measurement and all that is possible. So basically you have to create a interest group in your college saying that we are interested to do in this particular area. In the long run, that is very useful because the semiconductor industry is growing in India. So all these people will find opportunities in those semiconductor industries. And I suppose VLSI people would have known the next step after VLSI is almost getting saturated. The lithography dimensions, the time limits, the time constants, speeds are all getting limited. So what people call the next step of VLSI is called the silicon photonics. So you can use optical techniques to realize all that. So photonics is going to play an important role in VLSI.
So let's say that in the near future, the photonics is going to dominate technology.
Yes, people said, like electronics we have in the last century, you have this century, you have all the applications based on photonics. Already you have fiber optic communication. It has replaced all copper cables and many of these coaxial links and all that. Then biomedical applications. Photonics has played a bigger role than even electronics, like laser surgeries. You can do many of the operations you can do very easily. With the robotics, it is much more non-invasive. The laser beam, you need not cut the body to operate a particular object. You can focus such that it is not focused on the skin. The laser beam, you can focus inside to cut something or clean up something. So laser-based operations will become very important in the near future. Then what else? A lot of things which we don't know also. So photonics can be considered as an important feature. Only thing is, there are, for at least from our point of view, from students' college point of view, not much placements. Very few companies are there like BSNL or OptiWave Solutions, and some companies are there in India also. Even globally, not so much, most of it is appearing at a higher level than basic engineers. That's why we don't have courses in photonics, etc. But in the near future, you can expect you have a BTech in photonics, or MTech already is there. IIT Madras has got an MTech in photonics, and almost all institutions like NITs, IITs, they have got programs on optical science. So please get ready for photonics in the near future. So there's some positive things also in India. Interest is there, a lot of manpower is there. People are very good in mathematics also. For many of the, unless, see, most of the people are actually afraid of mathematics. They are not bad. If you overcome that in inertia, they will do very good mathematics. And according to me, maths is absolutely necessary for either photonics or quantum or whatever area you are working. If you overcome the what is that called, mathematics barrier, then it's very good for your quantum understanding. Any topic you reduce it to mathematical notation. Okay, fine, thank you. If you are interested, I'll show you a little bit of photonics, like a modulator or a switch. It's easier ones. In our lab, we have worked on sensors. We have made pressure sensors, acceleration sensors. Fiber optic gyroscope we made in our lab long ago when I was a student. Now that's a real device. It is used in our Nag, Prithvi and some of these missiles. And then recently they are working on, I mean, not our credit, but they are working on laser-based missiles also. You can shoot down the drones and all using laser beams. DRDO has projects on those. So some of these we worked earlier in our lab. Depending on your questions, I'll pull out these slides. You are welcome to interact, both technically as well as professional areas. So they have got a photonics chapter in this college, is it not? Inaugurated already? Your photonics chapter. Oh, you call the chair. Dr. Rajani is the chairperson of this photonics chapter now. This year, I think Mr. Venkatesh from Sai Vidya Institute. He is the chairperson.
No, this is
You already given your name, I know, I have seen that. Most likely we can put you as an EXCOM member. So you take up whichever is beneficial for your students.
And if you interact with the students also, let me see
See, there will be a meeting on 17th, photonics group. You can please come. They will send notice. 17th of this month. See, please don't confuse with IEEE AGM. This is only photonics group, small group. We'll have it in IIC, and you can debate what all to be done this year and all that. I suppose some of you are already IEEE members, not photonics. See, IEEE AGM is on 18th Sunday, 18th. You are aware, is it not?
ನನ್ನ ತಮ್ಮ ಅವನಿಗಾಗಿ ಏನು ತಗೊಳ್ಳಲ್ಲ, ಅದಕ್ಕೆ ನಾನು ಅವನಿಗೆ ಇದು ಬೈ ಮಾಡಿದೆ. ಅವ್ನು ಯಾವತ್ತೂ ಕಂಪ್ಲೇಂಟ್ ಮಾಡಲ್ಲ, ಆದರೆ ಎವ್ರಿ ಡೇ ರೂಟೀನ್ ಬ್ಯಾಕ್ ಪೇನ್, ಗ್ರೋನಿಂಗ್ ಮತ್ತು ಬೆಡ್ ಎಡ್ಜಲ್ಲಿ 10 ಮಿನಿಟ್ಸ್ ಕುತ್ಕೊಳ್ಳೋದು. ನಾನು ಅವನಿಗೆ ಈ ವೇಕ್ಫಿಟ್ ಆರ್ಥೋಪೆಡಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ತೆಗೆಸಿದೆ. ಇದೊಂದು ಜಸ್ಟ್ ಗಿಫ್ಟ್ ಆಗಿಲ್ಲ, ಒಂದು ಲೋಕಿ ಇಂಟರ್ವೆನ್ಷನ್ನೇ ಇತ್ತು. ಮೀಡಿಯಂ ಫರ್ಮ್ ಸಪೋರ್ಟ್ ಇದೆ, ಅವ್ನ ಬ್ಯಾಗ್ಗೆ ಹೋಲ್ಡ್ ಮಾಡುತ್ತೆ, ಫ್ಲಾಟನ್ ಆಗೋಗಲ್ಲ. ಫಸ್ಟ್ ಮಾರ್ನಿಂಗ್ ನೋ ಗ್ರೋನಿಂಗ್, ಜಸ್ಟ್ ನಾಟ್ ಬ್ಯಾಡ್.
ಅದು ಬ್ರೋ ಕೋಡ್ ಫಾರ್ ಲೈಫ್ ಚೇಂಜಿಂಗ್.
100 ನೈಟ್ಸ್ ಫ್ರೀ ಟ್ರಯಲ್ ಮತ್ತು 10 years ವಾರಂಟಿ. ಹಾನೆಸ್ಟ್ಲಿ ಅವ್ನು ಯೂಸ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆನೇ ನಾನು ಟೆಸ್ಟ್ ಮಾಡಿದೆ. ನಿಮ್ಮ ತಮ್ಮ ಇನ್ನೂ ಅದೇ 12-year-old ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾನ? ಅದನ್ನು ತೆಗೆಸ್ಬಿಡಿ, ಅವ್ನು ಕೇಳೋಕೆ ವೇಟ್ ಮಾಡಬೇಡಿ.
फर्स्ट थिंग्स फर्स्ट, 2 मुल्क बनने वाले हैं तो जाहिर सी बात है कि 2 नाम भी होंगे.
मेनन साहब, नामकरण तो नए बालक का होता है. अब जिन्ना साहब से कहिए कि अपने बालक का नाम रख ले, क्योंकि हमारा तो सदियों से एक ही नाम चल रहा है, इंडिया.
ऑर्डर्स है कि इस रेजिमेंट के हर सर्विंग ऑफिसर को किसी एक मुल्क को चुनना होगा, इंडिया या पाकिस्तान.
जो फौजी हमेशा साथ जीते थे, जिन्हें मौत नहीं बांट सकी, उन्हें ये सियासत बांट देगी.
Are you suggesting that the British have a specific date in mind?
15 अगस्त में ऐसी क्या खास बात है?
It's his lucky date.
आपने देश का भविष्य बर्बाद कर दिया है.
15 अगस्त को मकर का प्रभाव है, शनि दोष है. इस अशुभ स्थिति में जन्म लेने वाला सदा संकटों में घिरा रहेगा.
हमें तो उस बात के लिए तैयार रहना है जो सरहदों के तय होने के बाद होगा.
हिंदुओं के जलते घर बुझाने आए मुसलमानों ने पानी की जगह पेट्रोल फेंका. बाबूजी, पेट्रोल.
I want all 565 princely states merged with India.
सर, रजवाड़ों का कहना है कि उन्होंने अपनी सत्ता, अपना राजपाट इंग्लैंड की महारानी को सौंपा था, तो जाते हुए सब कुछ उन्हीं को वापस लौटाना चाहिए.
The power will reside with the common man.
And I will never accede to Pakistan or India.
बहुत अरसे से जेब में एक चेक पड़ा हुआ है, उसे कैश करने का वक्त आ गया है.
According to sources, इनमें से 10 लश्कर मुजफ्फराबाद के रास्ते वैली में घुसकर they've established controls.
इस नफरत को खत्म होना ही होगा.
बापू ने एक और आमरण अनशन की घोषणा करके अपने सबसे नजदीकी लोगों को भी चौंका दिया है.
बाप को अपने बच्चों में फर्क नहीं करना चाहिए.
इन 55 करोड़ रुपए का जिन्ना साहब क्या करेंगे? वो हमारे पैसे से गोलियां खरीदेंगे और हम पर ही चलवाएंगे. और मैं अपने देश का एक भी पैसा अपने देशवासियों के खिलाफ इस्तेमाल नहीं होने दूंगा.
कोई भी राजनीतिक फैसला बापू से बढ़कर नहीं हो सकता. आपको नहीं लगता कि अगर आपने बापू पर बयानबाजी करने वालों पर कार्रवाई की होती तो शायद ही हमला नहीं होता?
मेरा मंत्रालय मुझे चलाने दिया जाए.
जब अगर बायां बाजू है तो आप हिंदुस्तान के दाहिने बाजू हो.
अबू, बात ये नहीं है कि हम दोनों साथ नहीं चल पा रहे, बात यह है कि हम दोनों उल्टी दिशाओं में चल रहे हैं.
सियासत की इस गलती की कीमत इंसानियत को न जाने कितनी सदियों तक चुकानी पड़ेगी.
Freedom at Midnight Season 2, streaming now on Sony Live.
Vikram found the perfect package in seconds, so he could spend hours and hours relaxing. Expedia, made to travel.
Find your stay with Agoda. Fly away with Agoda. Have fun every day with Agoda. Travel your way with Agoda.
See the world for less. Book now.
we met on a Tuesday, it came in a box. Compact, efficient, and no fuss. And then, ta-da! Supportive? Check. Doesn't squeak or creak at night? Check. Doesn't toss and turn all night? Double check.
ಎವ್ರಿ ರೆಪ್, ಎವ್ರಿ ರನ್, ಎವ್ರಿ ಡ್ರಿಲ್ ನಿನ್ನ ರಿಕವರಿ ವಿಂಡೋ ಬ್ರೇಕ್ ಆದರೆ ಅದು ವೇಸ್ಟ್. ನಾನು ಹಾರ್ಟ್ ಟ್ರೈನಿಂಗ್ ಮಾಡ್ತಿದ್ದೆ, ಆದರೆ ಪ್ರತಿದಿನ ಬೆಳಗ್ಗೆ ನನ್ನ ಬ್ಯಾಕ್ ಟೈಟ್ ಆಗಿರ್ತಿತ್ತು, ಆಂಕಲ್ ಸ್ಟಿಫ್ ಆಗಿರ್ತಿತ್ತು, ಮೈ ಹ್ಯಾಮ್ಸ್ಟ್ರಿಂಗ್ಸ್ ವರ್ ಸೋರ್. 1 ಮಂತ್ ಮುಂಚೆನೇ ನಾನು ವೇಕ್ ಫಿಟ್ ಆರ್ಥೋಪೆಡಿಕ್ ಮ್ಯಾಟ್ರೆಸ್ಗೆ ಸ್ವಿಚ್ ಮಾಡಿದೆ. ಹಾನೆಸ್ಟ್ಲಿ ಫಸ್ಟ್ ವೀಕ್ನಲ್ಲೇ ಚೇಂಜ್ ಫೀಲ್ ಮಾಡೋಕೆ ಶುರು ಮಾಡಿದೆ. ಅದು ಮೀಡಿಯಂ ಫರ್ಮ್, ರಾತ್ರಿ ಫುಲ್ ನನ್ನ ಸ್ಪೈನ್ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಇರುತ್ತೆ, ವಿಯರ್ಡ್ ಡಿಪ್ಸ್ ಇಲ್ಲ, ಲೋವರ್ ಬ್ಯಾಕ್ ಪೇನ್ ಇಲ್ಲ, ಹೀಗೆ ಕಡಿಮೆ ಸೋರ್ನೆಸ್ ಅಂಡ್ ಕಡಿಮೆ ಇನ್ಫ್ಲೇಮ್. ನನ್ನ ಕಾಲ್ಗಳು ಫ್ರೆಶ್ ಆಗಿ ಫೀಲ್ ಅನಿಸ್ತವೆ ಮತ್ತು ನನ್ನ ಲಿಫ್ಟ್ ವಾರ್ಮ್ ಅಪ್ಸ್ ಫಾಸ್ಟರ್ ಆಗಿವೆ. ನಾನು ನನ್ನ ಸ್ಲೀಪ್ ಅನ್ನು ಟ್ರ್ಯಾಕ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಆಲ್ಮೋಸ್ಟ್ 6.5 ಇಂದ 7.5 ಅವರ್ಸ್ಗೆ ರಿಯಲ್ ರೆಸ್ಟ್ ರೀಚ್ ಆದೆ. ರಿಕವರಿ ಸ್ಕೋರ್ 14% ಅಪ್. ಅದು ಪ್ಲಸಿಬೋ ಅಲ್ಲ. ಎಲ್ಲರೂ ಔಟ್ಪುಟ್ ಮೇಲೆನೆ ಫೋಕಸ್ ಮಾಡ್ತಾರೆ, ಆದ್ರೆ ಶುರು ಆಗೋದು ನಿಮ್ಮ ಬಾಡಿ ರೀಸೆಟ್ ಆದ್ಮೇಲೆ. ನಿಮ್ಮ ಸ್ಲೀಪ್ ವಿಂಡೋನ ವೇಸ್ಟ್ ಮಾಡ್ಕೋಬೇಡಿ.
मॉर्निंग में 11 बजे मैंने अपना इंस्पेक्शन बुक किया था। जो स्पिनी से इंस्पेक्टर आए थे वो काफ़ी ऑन टाइम आए थे, मेरी जितनी भी क्वेरीज थी उन्होंने अच्छे से आंसर करी। सो बेसिकली जो प्राइस में जो कोट हुआ था ऑनलाइन और जो लाइक फाइनल प्राइस मेरे को रिसीव हुआ है वो काफ़ी अच्छा था एंड मैंने एक्सेप्ट किया। बाय 4 लाइक आई वॉज एबल टू सेल माई कार। डॉक्यूमेंटेशन भी पूरा वही देख रहे हैं और बेस्ट पार्ट है द बेस्ट प्राइस।
Priya added a hotel to her flight just because it had a floating breakfast. Expedia, made to travel.
From standing still to standing somewhere amazing with Agoda's great travel deals. See the world for less. Book now.
Hi everybody, if you're a Think School subscriber, this announcement is for you. People, in the past 2 years, we have grown Think School from 0 to 3 million subscribers by presenting the most powerful business stories on YouTube. And if you're someone who loves the way we tell stories, and if you also want to learn how to present your ideas in the most powerful manner possible, come join our Communication Masterclass course. This course is a 6 weeks course whereby I will take you step by step from a beginner's level all the way up to a TEDx level presentation skill. The best part is that if you have any doubts, I will personally talk to you during our weekly live sessions to help you overcome every fear you have. So if you also want to master your art of communication and if you want to present your ideas in the most powerful manner possible, come join our Communication Masterclass course by clicking the button below. And I will see you in the live session. Bye bye.
ನನ್ನ ತಮ್ಮ ಅವನಿಗಾಗಿ ಏನು ತಗೊಳ್ಳಲ್ಲ, ಅದಕ್ಕೆ ನಾನು ಅವನಿಗೆ ಇದು ಬೈ ಮಾಡಿದೆ. ಅವ್ನು ಯಾವತ್ತೂ ಕಂಪ್ಲೇಂಟ್ ಮಾಡಲ್ಲ, ಆದರೆ
I came to Saudi chasing a new fire, a new challenge. But what I found here goes far beyond the game. A pure blue sea where luxury is everywhere. I discovered a place where hundreds of years of culture still stand strong. A vibrant and magnetic coastal city where life flows towards the sea. Places that make you feel alive, like nowhere else. And ancient wonders that bring you serenity. I came for football, I stay for more.
This is the new Dell AI PC, built for AI. It's like a trusted personal assistant. Learning your habits, keeping you on track. But it can't make your coffee, yet.
कुछ सोचता ना कुछ कृपा के लिए, ऐसा चमत्कार के लिए, तो उसके साथ हो
Priya added a hotel to her flight just because it had a floating breakfast. Expedia, made to travel.
In the corporate world, if you come across as too nice, people don't respect you more.
ಎವ್ರಿ ರೆಪ್, ಎವ್ರಿ ರನ್, ಎವ್ರಿ ಡ್ರಿಂಕ್ ನಿನ್ನ ರಿಕವರಿ ವಿಂಡೋ ಬ್ರೇಕ್ ಆದರೆ ಅದು ವೇಸ್ಟ್. ನಾನು ಹಾರ್ಟ್ ಟ್ರೈನಿಂಗ್ ಮಾಡ್ತಿದ್ದೆ, ಆದರೆ ಪ್ರತಿದಿನ ಬೆಳಗ್ಗೆ ನನ್ನ ಬ್ಯಾಕ್ ಟೈಟ್ ಆಗಿತ್ತು.
सही सी बताइए, तुझे मेरा दुबई घूम के मजा आया ना?
तू ये बता, तुझे मेरा दुबई घूम के ज्यादा मजा आया कि नहीं आया?
मैं कह रहा हूँ जनता से पूछते हैं कौन सा दुबई में।
With Udemy, there's a world of possibility at your fingertips. With one click, you're in the leading online marketplace for learning and skills. Want to become an AI expert? This is learning from real-world experts.
Dell AI PC, built for AI. It's like a trusted personal assistant. Learning your habits, keeping you on track. But it can't make your coffee. Yet.
I came to Saudi chasing a new challenge. But what I found here goes far beyond the game. A pure blue sea where luxury is everywhere. And ancient wonders that bring you serenity. I came for football, I stay for more.
ನನ್ನ ತಮ್ಮ ಅವನಿಗಾಗಿ ಏನು ತಗೊಳ್ಳಲ್ಲ, ಅದಕ್ಕೆ ನಾನು ಅವನಿಗೆ ಇದು ಬೈ ಮಾಡಿದೆ. ಅವ್ನು ಯಾವತ್ತೂ ಕಂಪ್ಲೇಂಟ್ ಮಾಡಲ್ಲ, ಆದರೆ ಎವ್ರಿ ಡೇ ರೂಟೀನ್ ಬ್ಯಾಕ್ ಪೇನ್, ಗ್ರೋನಿಂಗ್ ಮತ್ತು ಬೆಡ್ ಎಡ್ಜಲ್ಲಿ 10 ಮಿನಿಟ್ಸ್ ಕುತ್ಕೊಳ್ಳೋದು. ನಾನು ಅವನಿಗೆ ಈ ವೇಕ್ಫಿಟ್ ಆರ್ಥೋಪೆಡಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ತೆಗೆಸ್ದೆ. ಇದೊಂದು ಜಸ್ಟ್ ಗಿಫ್ಟ್ ಆಗಿಲ್ಲ, ಒಂದು ಲೋಕಿ ಇಂಟರ್ವೆನ್ಷನ್ನೇ ಇತ್ತು. ಮೀಡಿಯಂ ಫರ್ಮ್ ಸಪೋರ್ಟ್ ಇದೆ, ಅವ್ನ ಬ್ಯಾಗ್ಗೆ ಹೋಲ್ಡ್ ಮಾಡುತ್ತೆ, ಫ್ಲಾಟನ್ ಆಗೋಗಲ್ಲ. ಫಸ್ಟ್ ಮಾರ್ನಿಂಗ್ ನೋ ಗ್ರೋನಿಂಗ್, ಜಸ್ಟ್ ನಾಟ್ ಬ್ಯಾಡ್.
ಅದು ಬ್ರೋ ಕೋಡ್ ಫಾರ್ ಲೈಫ್ ಚೇಂಜಿಂಗ್.
100 ನೈಟ್ಸ್ ಫ್ರೀ ಟ್ರಯಲ್ ಮತ್ತು 10 ಇಯರ್ಸ್ ವಾರಂಟಿ. ಹಾನೆಸ್ಟ್ಲಿ ಅವ್ನು ಯೂಸ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆನೇ ನಾನು ಟೆಸ್ಟ್ ಮಾಡಿದೆ. ನಿಮ್ಮ ತಮ್ಮ ಇನ್ನು ಅದೇ 12-year-old ಮ್ಯಾಟ್ರಿಕ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾನ? ಅದನ್ನು ತೆಗೆಸ್ಬಿಡಿ, ಅವ್ನು ಕೇಳೋಕೆ ವೇಟ್ ಮಾಡಬೇಡಿ.
आयशा फीडबैक कौन दे रहे हैं? अच्छा वोट ऑफ थैंक्स
ಸರ್ ಐಟಿ ಅದು ಮೈಕ್ ವರ್ಕ್ ಆಗ್ತಿಲ್ಲ ನೋಡಿ, ಆನ್ ಮಾಡಿ. ಹಲೋ ಹಲೋ ಸರ್, ಜಲ್ದಿ आओ. क्या सर? But for whom we should ask from Tabassum ma'am? Excellence is never an individual act, it is the result of collective commitment. A very good afternoon to our respected dignitaries on the dais, esteemed resource persons, faculty members, and dear participants. We warmly welcome you all to the validatory function of the 6th-day AICTE approved ATAL Faculty Development Program on Bits to Qubits. This FDP has been a journey of learning and exploration, bridging the gap between classical computing and the emerging paradigm of quantum technologies. To begin this auspicious occasion, I request Professor Afrin Kubra to kindly deliver the welcome address and set the tone for today's valedictory function.
It gives me immense pleasure to welcome you all to the valedictory function of the 6th-day AICTE-sponsored ATAL-FDP on Bits to Qubits. Over the past 6 days, this FDP has taken us on an enriching journey from classical computing to fascinating world of quantum computing, fostering learning, interaction, and intellectual growth among all participants. At the outset, I extend a warm and respectful welcome to Shri C.M. Ibrahim Sahib in his absentia, Shri C.M. Faiz Muhammad in his absentia, to our esteemed dignitaries on the dais, whose presence adds grace and significance to this occasion. I now request Dr. Tabassum Ara, convener of this FDP, to kindly welcome our respected principal with a token of gratitude. I now request Dr. Arya to welcome Dr. Tabassum Ara with a token of appreciation for her dedicated efforts in successfully convening this FDP. I request Dr. Abdul Aziz to welcome Dr. Manjunath R. Ponte, Dean Academics, with a token of gratitude, recognizing his constant academic support and guidance. I now request Professor Noor Aisha to welcome Dr. Ravindra with a token of love. I also warmly welcome all the faculty members and the participants who have actively taken part in this FDP and contributed to the success through their enthusiasm and engagement. Once again, I welcome you all to this valedictory ceremony. Thank you.
Thank you, ma'am, for this gracious and warm welcome. Now, it gives me great pleasure to invite Dr. Tabassum Ara, convener of this ATAL Faculty Development Program, to address the gathering and share her valuable thoughts on the FDP and its outcomes.
Honorable Chair,
That's my
Honorable Director, respected Principal, Dean Academics, HODs, faculties, and dear participants, a very good afternoon one and all.
On your ID card.
This 6 days journey have been started 6 months ago, but I don't feel like it is closing. Honestly, I was trying to discuss with my team what's the plan for on Monday. How are we prepared on Monday? to conduct the session, who is the resource person, how to continue. So it's very hard to believe that we are at the end of the faculty development program. So at the same time, I believe that this is not the end of the journey, this is the beginning of the journey, right? So one kickstart we have got it from very resource people from different areas, the industry, the IIT, from IISc, and from our own institution, our respected principals. It was great right from the day one, right? Applying the proposal, right? And I'm very grateful to our principal sir, who have always trusted me and my team, right? Who have given me an opportunity to apply for this, and with our team effort, we could get this grant also. I don't think quantum computing FDP, many people have received this grant. So, sir, I request you to allow me and support me to apply for the advanced FDP. This is a basic FDP. So probably next year we'll apply in the same area, and I'm sure that we all will have some outcome of this FDP to present it in our advanced FDP. Well, to start with, I would like to express my heartfelt gratitude to our resource people. Let me just name it, we should not forget them, right? Of course, we have all the resources which they have shared with you, which will always remain with us, and the YouTube link also. And maybe at the end of the day, all the links, share it with all the participants, right? So we started our journey, as you know, from Dr. Rajshekhar, right? He is from Dell Technologies, and he is purely working in the same area. He was very curious when I spoke to him. He was very interested to come and deliver the session, and he wanted the entire day. There were two people, who never wanted, who never objected when I gave 2 sessions. And in fact, at the beginning only they had told me, when I asked what are the contents you would like to deliver, tentatively these are the schedule which we have. Then Dr. Rajshekhar has shared me the content to be delivered. The content itself was more than 1 page. The headings, the topic. I had to reduce the content, and then he told one day also will not be sufficient for fundamentals also. So anyway, so we are very blessed that for the entire day, 2 sessions he could spend the time with us and delivered a very rich content, right? And then the second day we started with Dr. Pallavi, right? So Dr. Pallavi, you all know that including principals, Manjunath sir, Ravindra sir, so many other HODs were there, faculties were there, and I also had taken the notes from end to end. And I, trust me, most of the time I used to feel that I'm very fast. Okay, I'm very fast. I was not catching her speed. When I'm writing the equation, I'm missing her the explanation. When I'm listening to her, I'm missing the writing. Right, so then finally I could match. I tried. Initially I was not able to match the speed. Yeah, but later I started, I have a complete notes, I have taken from Pallavi madam. Amazing professor. We are blessed to have her here, and I'm happy that our team, principals, all other HODs, faculty teams, the organizing team have helped me a lot to get the resources on this single platform, right? And we had Dr. Varun Kumar sir from IISc, right? And we had Mr. Ajmal, right? I had to connect him through one of my students who got placed in quantum company, in his company itself. Then one fine day we were discussing like one more resource person we needed. So it was principal sir who suggested me, why you don't try to contact him, since that is a startup which is purely in quantum. Quantum X itself is the company. So he was also, the candidate was very happy that yeah, my boss will be coming to the campus. So it was great, and he was kind enough, to accept the invitation. Right, so it was great to bring him on this platform. Then we had Jay Kumar sir. Yeah, Jay Kumar sir, I am connected since more than 2 years, I think. He is the person who is not in his headquarters, I mean to say in his hometown for a day also. Even on the weekdays he is traveling. He travels throughout the country, right? He has visited all the IITs, NITs, right? And he is from he has his own startup, right? Anutantara, right? Earlier I didn't know what is Anutantara, some name he must have coined it for his company. But in the session he told Anu is an atom and Tantara is a technology. So basically it is quantum itself, right? So he is also one of the great resource, and he gave a very beautiful journey how anybody can start and become a mentor, right? So, and yesterday's session, Dr. Telagavati, right? She was also amazing professor, right, from SRM. It's very difficult to connect also. Many people are there, they don't even accept the request, LinkedIn request, right? So if they don't accept the LinkedIn request, it means that they are not reachable. If they are not reachable, how can they share their knowledge, right? But whoever I have tried to connect, and trust me, sir, almost all the people except the ISC people, everybody I connected only through the LinkedIn. They are amazing. In no time, they accepted the request, and through LinkedIn itself, I have communicated and placed them onto the platform so that they can come and deliver their lecture. So it was a great journey, and the entire 6 days FDP, right? A cherry on the top was done by our justified this statement, cherry on the top by our respected principal. Sir, it was amazing lecture. I missed a few things, but I'm very confident that I have the YouTube link. And trust me, he didn't use the projector. That's the reason. With all the lights, bright light has come in his lecture. It's not about only the electricity. I believe it is not because of electricity. It is because of his aura. Do you agree this? Yes. Yeah, it was great to have sir as a part of this program. Of course, he was a backbone for this entire FDP, but as a resource person also, he spent his valuable time. We invited everybody to attend the lectures, but sir was the backbone, sir was the resource person, and sir was the participant. Right, sir, I'm sorry, I cannot request AICTE to give you any certificate, as a participant, because you are above all. You have crossed all those things. It doesn't make any sense to give you any participation certificate. So it was a great journey. So I cannot, it's not, I mean, one thank you word is not enough for the organizing team, right? So 1 week before we started our preparation, it's not like only the EIML team was active. I did not see even the time when I was texting. Even the late evenings also I have troubled them. And I would like to take their names, right? We have Professor Afrin, Professor Nelvita, Professor Muskan, Professor Ashish, Professor Bharat, Professor Arun. Where is our Arun sir? Yeah. See, he always sit at the last, but when it comes to his responsibilities, he will be the first person. We have Muskan, we have Deepa, and we have our student representative also. He is my intern, Mr. Shreyanshu. And apart from this, I would like to thank Dr. Manjunath sir, who has delegated, three faculties from 2 weeks. They were with me. I don't know, they were missing from their own department. They were not there in the EC department. They were here. So Aisha Noor, Professor Noor Aisha, Professor Dr. Arya Lakshmi, Dr. Abdul Aziz, and last minute also they could arrange the Dr. Srinivas sir. Hats off you too, sir. So the entire organizing team, you are amazing. Okay, so let's continue this journey, right? I would really appreciate your efforts. Without your active efforts, this could have not been successful. Yeah, sir, most of the resource person, especially the Dr. Jai Kumar, as I told, he keep visiting entire nation. He just asked, I want internet. So Mr. Faik told, just click on this. He just clicked it and it just connected without any username, password, no hassle-free. With one click, he got the internet and he announced it. This is the first time I am seeing the internet with one click. In most of the esteemed institution, I never got it. Later also, he mentioned the same thing. I visited so many NITs, IITs, the deemed to be universities everywhere. But I used to struggle to get the internet connection. So beautifully it was, managed. And 2 days, I think 1 week before, Faik sir had told me, ma'am, I'm creating one small hotspot for this event itself, ATAL-FDP. Any participant, it's a free access, just click it, you will get it. So, IT team, Mr. Faik and his team, it was great. And Mr. Faik was telling me he has learned what is quantum now. So the entire team has learned the fundamentals of quantum computing. Sir, you attend one more FDP, and definitely, you will be able to certificate. Yeah, you can take the assessment and you will get the certificate also. It was great. Thank you so much for your assistance in the entire audio-visual setup, the live YouTube streaming, and the live recording also, right? Last time, Vani FDP also, the same kind of support was extended by the team. So, sir, thank you so much, Faik sir and team. So, only words are not enough to express my gratitude. I would like to request Principal Sir to give them one small token of appreciation for the entire team, right? So I would like to call Professor Afrin.
Great.
Thank you, sir.
Professor Nevita. Dr. Arya Lakshmi. Dr. Abdul Aziz. Special thanks to Dr. Abdul Aziz sir for end-to-end support. Professor Muskan. Professor Arun. Professor Gayatri, Dr. Gayatri. I forgot to mention her name at the beginning. She is also part of the organizing team. Thanks for the support, madam. Professor Ashish. Miss Deepa. Last but not the least, I cannot forget my host, Professor Nuraisha. Aisha, you give it to Shreyanshu. Mr. Shreyanshu.
Tanmay, sir.
Tanmay. 5x, sir.
करेक्ट सेट को यहाँ से
And throughout the entire FDP, one participant you all have witnessed. There were two participants. One participant left little early. I think Professor Arun Kumar.
Arun Raj.
Arun Raj. Professor Arun Raj, please come and collect one token of appreciation for being an active participant. Professor Annapurna was another active participant, but still, we will try to send her to her college, right? That's it. So two more, the support I had from the day one, Dr. Manjunath sir, Dean Academics, and Dr. Ravindra sir. They were there, back end support, I can say, in my all discussion, in my all challenges. They were guiding me and they were supporting me. Thank you so much, sir. I would like to thank our non-teaching staff also, Tanmay,
Salim,
Ganga, and then Mamta, and then Aksa. Thank you so much. So as I said, this is not the end of the journey. This is the beginning of the journey. So let's see some outcome of this FDP. I want this group to be active, right? We are not going to, we request you not to leave the group, right? As I told, Srinivas sir also was telling so many resources he told he will share with us, recent papers he was talking about. So the resource persons who were involved in this FDP, they all have committed that they will continue this journey with us, especially in terms of research. So I request each participant not to leave the group, right? We will continue this group and we will learn many more things. Lots of free certification courses are also available. Every resource will be shared in this group. Let's have a great journey. Let's start a new journey, I can say, in the area of research. Thank you, sir. Yes, the very first in the inauguration I had mentioned, I just want to mention once again this initiative which AICTE has taken. I was just trying to fill the feedback today, right? So beautifully they have asked the question, right? What was the challenge in registering the participants? They are asking all these details. What were the challenges in arranging the resource people? So I'm just mentioning one or two questions. I have not yet filled. So 7 pages are there for, as a coordinator, I have to give the feedback. So they are asking a lot of details. It is not about yes or no. They are asking, give one paragraph of challenges which you have faced and how can AICTE help to resolve your challenges maybe in the further FDPs, and what are the different thirst areas which you want to add it to the existing list. Like this 7 to 8 pages of feedback I have, I should appreciate the efforts which AICTE has taken. You know, one side they are taking this initiative, the other side the thirst area they are giving it, right? And the platform also they are giving. Sir, right from the application, opening of application till the closing of application, entirely through the portal. Okay, and we have taken the assessment questions from the every session. It is uploaded. Now, anytime you can take the assessment. It is a 30 minutes assessment. 45 minutes I have given. 30 questions are there, and all questions are MCQ. Each question carries 1 mark. Right, and that assessment is also again through the AICTE portal. So beautifully they have designed. They are asking the feedback of the portal also. So I would like to thank it. I want to express heartfelt gratitude to AICTE who have given this opportunity to HKBK College of Engineering to conduct this basic FDP in quantum computing. Thank you. Thank you so much.
Thank you very much, ma'am. Now it gives me a great pleasure to invite Dr. Mohammad Riaz Ahmed to address the gathering and share his valuable thoughts on the FDP and its outcomes.
It is very tough to talk after Tabassum madam. She so gracefully thanked everybody. I am feeling like a resource person now. Thanks for the opportunity. For the first time I spoke about quantum in front of anybody. It was a great platform. There is a gap between academics and industry, and academics is much far ahead than industry. I want you to realize this. Many times people write articles, and in the panel discussion they use this. Even the street vendors who come to our college to sell projects and also who want to do FDP for our faculties, they tell us, sir, there is a gap, huge gap between industry and academics. I say, yes, we are much ahead of industry. So it is industry people who have to come behind us. And I will prove it. Because in 2012, I registered for PhD in reinforcement learning. Okay? The industry is behind AI now. And they have not even reached to reinforcement learning. They are still stuck with deep learning. And with only LLMs, they are driving the industry this much. But we did PhD on reinforcement learning in 2012-13. And my student did PhD on spin quantum, and he got awarded in 2021. Now AICTE is giving fund to conduct FDP, and now industry is still staring at AI. Still they have not matured to quantum. And if I simulate today, I can go with 32 bits, but in industry they don't even have more than 4 or 6 bits, other than IBM, which is not in India. So what I am saying is, there is a huge gap between academics and industry, where academics is much, much ahead of industry. The journals, what we write, industry cannot implement. The theory, what we propose, industry cannot implement those things. So have this kind of mindset. It is all the people outside who are criticizing teaching, who are criticizing education system, who are criticizing teachers. Call them to your college, ask them to take session for 3 hours, then they will come to know. So this is the only place where we help each other. This FDP, we develop each other, we share among ourselves, we have a dialogue to see what we have learned from the previous scenario to this scenario. Right now, at least 30-36 people, we are here sitting and contemplating about quantum, but in industry, they don't even talk to each other which certificate they have completed. Here we celebrate, we felicitate anybody who completes PhD. We put it in the WhatsApp group. If somebody publishes in Q1 journal, we give incentives if somebody is getting a granted patent. But in industry, that is not the case. So we are much ahead than industry, either in humanity or also in knowledge. It is only they who are lacking behind. They are not behind us to implement those things. So let them come to us. We have 32-bit algorithm right now ready. Can they implement? No. Academics is much ahead than industry. And there is a huge gap. Industry should come to us, to the portals of college, and fill that gap. If you have this kind of mindset, if you have this kind of attitude, I am sure that same confidence will go to your students. And when that confidence is reflected in your students, in their eyes and in their resume, I am sure that industry will flourish with our knowledge what we have done here. So faculty development is not directly faculty development. It is a loan to the faculty so that it becomes SDP, student development program. If it doesn't convert into student development program, then that loan will be with you. You are a defaulter. Artha hai? So you have taken a loan of knowledge from all the arrangements. Now this has to be passed to the student development program. So you have to become resource person in your college. With the same content, same material, every session 1 hour. Jay Kumar says 1 hour, Pallavi Madam's 1 hour. You take those contents, 5 hours, you create a poster in your college and you start executing that. Let us do mistakes. That's what I told you. Fake it until you make it. Now we are faking that we have quantum bits and we are writing papers. And I'm sure that within 10 years we will have at least 1121 qubits. So we have to do this. Until you don't do that, then the FDP meaning will not be complete. Okay. Special thanks to IT department for making my video bright. I went to my home, I showed to my wife, see. ये होता है quantum. And all the resource people, I learned from them. It was very amazing, especially coordinators and the way they coordinated. I feel that if I had worked under Tabassu Madam, I would have learned more leadership than what I am having today. A big round of applause to all the coordinators and Tabassu Madam for executing this event. Madam, thanks for the opportunity so that though we are in administration, we always get drained with many things. The moment you said you will have one session for 3 hours, since that day I am behaving like a fresher employee, trying to impress the topic. I will do in this way and in this way. And whenever you shifted my schedule, my complete flow has to change. Because what I speak on first day cannot be spoken on 4th day. And I don't know what they are speaking, so I have to sit, I have to see the video, I have to go through the YouTube in the night, what today they have spoken, and I have to remove those things from my content. And I have to fill the gap which they have not covered, which they were not allowed because of the time constraint. So thank you for that opportunity and appreciate the efforts and leadership and maturity of Dr. Kaunte. Without any ಇದು ಯಾವ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಯಾರು ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಯಾಕೆ, ನಮ್ಮ ಯಾಲಕ್ಕಿ ಎಲ್ಲಿದೆ, ನಮ್ದು ಅಕ್ಕಿ ಕಾಳು ಎಲ್ಲಿದೆ, ಅಲ್ಲಿ ನಮ್ದು ಕ್ಯಾಪಿಟಲ್ ಲೆಟರ್ಸ್ ಅಲ್ಲಿ ಹೆಸರು ಬಂದಿಲ್ಲ, ನಮ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಮೆನ್ಷನ್ ಆಗಿಲ್ಲ. He never bothered about that. Madam called, he came, and I told sir they want human resource, let the team focus on execution. And then said, okay sir, we will take care of stage and program committee. And it is not only because of your goodness sir, it is because of your team's goodness. Dr. Arya, Dr. Abdul Aziz, Captain will. So very good coordination from EC department. Now I appeal to all the participants. First of all, thank you for being with us. And let me tell you, we wanted genuine people. And I told you in the day one, we had 70+ registrations. I made madam to disapprove. Okay, we had our own exercise to see who is genuine, who is going to be there for all the days. So now I am sure we will apply for the next level of quantum and we will get funding for that. I manifest it, madam will manifest, it will happen. That day I will tell you what I have done from today till that day in quantum. I will present my progress report. You also should register for that and you have to give progress report on that day. What you have done in these many days from the basic quantum FDP to the advanced quantum FDP. We have exposed you to very good resource people, especially Jay Kumar, who has given you the ladder of certifications, the flow of certifications. You should have minimum 2 certifications. You should have minimum 2 patents. You should have minimum 2 papers, at least 1 Q2 journal about quantum on the quantum area. And if you do this and if we get next level of quantum FDP, then the cycle is complete, then we will become a resource person. Then we can say happily that yes, I know something about quantum and we are beyond industry and we can talk about those things. So the WhatsApp group will continue and I will also put all the notes which I have prepared also, and the write-up what I made you to write, that also color wala, color scan karke, I will put it there. I will share all the notes, okay? And I will also share the 43 papers which I have referred to get the contents of that. Keep the WhatsApp group alive. There we will post even postdoc openings in quantum. Madam and I, we are a part of consortium of quantum throughout the world. And right now, we have some opportunities of postdoc in Australia. So, Madam is also doing her postdoc in Dubai on quantum. So, we will post the postdoctoral options. We will post the journals who are aggressively reviewing quantum papers, and also we will also give details of people whom you can put as reviewer so that your acceptance will be very fast and criticized, and all the corrections can be done directly so that it don't need to be in the cycle of 3 months and 3 months of journal. So keep the WhatsApp group alive, and also look forward, pray that HKBK get more funding in quantum and you be the first beneficiary of that. You be the first copy of all the qubits what we receive from the universe. Once again, thank you all of you. Thanks for being here and making it more entangled so that we always spin together, and we also always have that knowledge of superposition that we keep on sharing so that we interfere and make best professors, best teachers out of ourselves, because this is the only profession where respect is still remaining, where people will come to you, even the parents, no matter they are MLA or MP, when they go to meet the teachers, they will be behaving like this, sir, namaste, sir. So that respect, let us justify. Let it not be a tradition. Let it be justified by us. So there is a gap. We are ahead of industry. Academics is ahead of industry. Let us prove that. Let us have papers. Let us have patent. Let us have FDP, and let us be resourceful people on these domains. Thank you. Thank you, one and all. And special thanks to Government of India for taking such an initiative. Quantum Mission, National Quantum Mission is a very aggressive thing. Even Karnataka has responded multifold, and we are in competition with Andhra Pradesh, who also have announced 1 crore for anybody who gets Nobel Prize in quantum. So let us all work towards that so that we set landmark milestones for the next generation to look forward. The generation is very confused, and we have to set some rules, guidelines, and landmarks and milestones. Let us do that job from our side. Thank you, AICTE, for funding this. Look forward for more applications and funding from you. In the WhatsApp group, we will share the call for proposals also. Okay.
Thank you, sir, for the insightful and motivating presidential remarks. And FDP is truly successful when the learning experience of its participants is enriching and impactful. At this juncture, we would like to hear directly from our participants. I now invite a few participants to share their feedback and experiences about the 6-day ATAL-FDP on bits to qubits. We kindly request the participants to come forward and share their feedback.
Only external. Let me just connect this.
Good afternoon, everyone. This is Maitri from ATM College of Engineering, Mysuru. Actually, I and my co-colleagues, we had a paper on quantum memory circuit design. So that was getting rejected, and again we have applied it for some other journals. So with that intention, actually I attended this FDP so that I'll get to know why actually our paper is getting rejected, and also to understand what is this quantum computing as well. So the 6 days FDP was really well organized, and I'm very happy to be a participant in this college. Although I was traveling from Mysore daily. So actually I didn't lose anything. Yeah, I have gained the knowledge, and very much thankful, and as well as the food was very good. Thank you so much. Because previously I had attended the ATAL-FDP in other college, and food was not to that extent actually. So food was very good here. So all the day the menu was changed. So thank you for that as well. And the hospitality or whatever was there was very good here. And the knowledge, actually first 2 days it was completely on the mathematical and physics where I was a bit confused. And the third day the person who came from the IBM, actually that day I was able to connect to the first day and the second day. And till today, then I got to know by the last 6th day I was able to understand what is actually the quantum bits like electron and protons. For the first 2 days I was not able to understand what actually the qubits were. So very much thankful now, at least I'm able to understand what is quantum bits and what is quantum computing, and yet to explore many more things in this. As the sir said, the group will be active. So thank you for that, sir. And as well as you mentioned that few journals, reviewers will be posting it. So that would be very much helpful for me.
You should thank you for the FDP.
Sure, sir, sure. So thank you one and all. Thank you for the team for well organizing it. Thank you. Thank you for the HKBK management as well as thank you for the ATV management for giving me the opportunity to attend here. And as sir said, we have to transfer this knowledge to the students, and in our college we have a procedure that we have to transfer this knowledge first to the faculties. As soon as I go to my college, I have to prepare a report as well as I have to disseminate to my department as well first. Then we can transfer the knowledge to the students. So that is the reason I asked ma'am what about the resources that is. Then she said she'll be sharing them shortly. So next week we have to prepare a report and disseminate to our department. So that is the procedure in our department, in our college management. Whoever goes to the FDP, they have to do the knowledge transfer first to their department fellow people. So that, and also they'll ask what collaborative works that when you meet there, what collaborative work that can be like enhanced or can be more improvement that can be done in our college as well. So so with all that things, I would like to thank both the college management. Thank you, Monica.
Please, can you put it in your pocket?
A very good afternoon, everyone. In fact, I'm really happy that I'm part of this FDP. Usually, FDP will not only update your knowledge, it also upgrade your thought process or mindset. That's the first thing what I would like to express. In fact, let me explain my journey to this FDP. I was initially searching for a quantum computing FDP near to my college. That was my first requirement. I think that requirement met here. And also, I wanted this FDP in a very short span of time. In fact, when I saw the title, that is Bits to Qubits, I was really impressed. It's something like before entering a restaurant may look very fancy and very lucrative. But after entering the restaurant, after having the food, then you will decide whether I should revisit or not in the real life. Same thing happens here, but I'll definitely revisit next time for the HKBK. Because really I'm impressed by the way the flow has gone. I sincerely thank head of the department, for your excellent execution. I could see your blend of elderly and youngsters working for the FDP. I really thank you. In fact, always the validatory function may tell good things, but there is a learning in the validatory also. As principals are rightly mentioned, after going through this FDP, that has to be disseminated to the student community. That's our, as a teacher, that's our ethics, I feel, personally. I think definitely, sir, we'll do that work sincerely. Once again, I sincerely thank HKBK and your leadership for this excellent FDP. Thank you, everyone.
In spite of his busy schedule, sir is vice principal and I know the pain. So I request to the coordinator with her permission, I want to express a small token of appreciation to Mr. Please. ನೀವು ಮೈಸೂರಲ್ಲಿ ಅಪ್ಡೇಟ್ ಆಫ್ ಮಾಡೋದು
Thank you, ma'am, and thank you, sir, for your valuable feedback and kind words. As a mark of our sincere appreciation for their efforts, I invite our coordinators to come forward and receive their certificates. I request the dignitaries on the dais to kindly present the same. For the coordinators, Dr. Arya Lakshmi, Dr. Abdul Aziz, Professor Nelvita Fernandez, Professor Noor Aisha, Professor Afreen Kubra, Thank you.
Go back and say thank you.
Thank you. Now, as we approach the conclusion of this valedictory function, I invite Professor Noor Aisha to deliver the vote of thanks.
Good afternoon, everyone. Once again, it gives me immense pleasure and a deep sense of gratitude to stand before this august gathering and propose the vote of thanks on the valedictory function of 6-day AICTE approved ATAL Faculty Development Program on Bits to Qubits, Transforming Technology with Quantum Computing. At the outset, I express my sincere gratitude to AICTE and ATAL Academy for approving and supporting this faculty development program, which has provided a valuable platform for knowledge enrichment and academic advancement in the emerging domain of quantum computing. I would like to express our sincere gratitude to our respected chairman, Shri C.M. Ibrahim Sahib, and director, Shri C.M. Faiz Mohammed, in their absentia, whose visionary leadership and unwavering encouragement continue to inspire us to strive for excellence and shape the future of our institution and its students. I sincerely thank our principal, Dr. Mohammad Riaz Ahmed, for his continuous support, encouragement, and leadership in making every academic initiative meaningful and impactful. I would like to place on record my special appreciation to Dr. Tabassumara, convener, for her dedicated efforts, meticulous planning, and effective coordination, which played a pivotal role in the successful conduct of this FDP. I would also like to extend my sincere thanks to Dr. Manjunath R. Counte, Dean Academics, for his constant academic guidance and support. I take this opportunity to acknowledge all the esteemed resource persons for their meaningful contributions that significantly strengthen the learning outcomes of this FDP. I express my gratitude to all the heads of various departments, associate deans, and IQSC coordinators for their cooperation and encouragement. My heartfelt thanks to all the external participants for gracing this occasion and enriching the program with their presence for all the 6 days. I also sincerely thank all the internal participants, especially from the Department of ECE, CSE, ISC, and Mechanical Engineering, for their enthusiastic involvement and active participation throughout this FDP. A special word of appreciation to all the coordinators, organizing committee members, and our dedicated student volunteer who worked tirelessly behind the scenes to make this event smooth and successful. Last but not the least, I thank each and everyone who has directly or indirectly contributed to the success of this program. Once again, thank you all for being a part of this memorable occasion. I request all the participants and the esteemed dignitaries to join for the group photo.